What's up, guys? Welcome back to the channel. Today on this video we will be doing the question paper that you see here. I hope you guys are ready because this is gonna take a little bit of time. And as you can see, this is a question paper for mathematics N4, and this was written on the 28th March 2018. It took about 3 hours for this question paper to be complete. Now I don't know how long it's gonna take us, but it's gonna take us that long. I think it's gonna take us more than 3 hours. But I hope you are ready, guys, to watch how we solve some of the problems that we have here. So, guys, all I can say is get ready and let's get started, man. Let's get started with question one. All right, so let me just scroll to question one. All right, this is our question one of this question paper, of this previous question paper. So I'm gonna put it here so that we can able to do it. We need more space though. So 1.1, so you are given the following function there. This is a cubic function. As you can see, we have x to the power of 3 plus 5x squared plus 2x minus 8. Now they want us, guys, to solve this problem. Now let's read the statement and see what exactly is it that they want us to do there. Now they say use differentiation to calculate the coordinates of the turning points and the point of inflection of the given cubic function. Distinguish between the maximum and the minimum turning point by using the second derivative. All right, now as you can see, or as we read here, there are three things that they want from us, guys. They want us to first get the point of inflation. Let me just highlight the point of inflation. You guys see? Now, the second thing that they want us to do, in fact, two things that they want us to do. They want us to get the maximum, and the minimum turning points. And also we must distinguish between the two by using the second derivative. By now you should able to do this, but if you don't, just stick around. I hope this video is going to help you. All right, guys, let's start. So first of all, when we find the maximum or the turning point of a cubic function, we need to do the derivative. So let me just do this. Yeah, we need to do derivatives. So meaning we need to derive this function here. We need to find the derivative of this function here. Now, as you can see, this is a standard derivative, so we won't be having any problems there. But before you do that, you need to understand that dy over dx, or a derivative of the function, is equal to 0. Right? Now let's find our dy over dx of the function there. Now if we derive the first term, we're gonna have 3x squared. There we go. And when you derive the second term, we're gonna have plus 10x. And then when we derive the third term, we're gonna have plus 2. The last term, as you can see, it's only 8. It's a constant, so that is going to be 0. We don't write it here. And then this is going to be equaling to 0. Do not forget the derivative is equaling to 0. Now if it so happen you don't know how this derivative came about or how did we do it, there is a video here. Go and watch that video. It's about standard derivative, guys, but I assume that you know that already. But if just in case you don't understand, all right, now it's time for us to solve for x when it's like this. Now when it's like this, I would advise you guys to use the quadratic formula. Remember, the quadratic formula is this formula here. When you have x is equaling to negative b plus or minus square root, and then we have b squared minus 4ac divided by 2a. all right, now here you must able to identify your a, your b, and your c. So let us write them here. So a, when you look at this the derivative, a is gonna be 3, and then b is gonna be positive 10. and then C here it's 2. So we have to substitute this here there. Remember, this is from our polynomial, where we know that y is equaling to ax squared plus bx plus c. Okay, I hope you can able to see this. I don't have enough space, that's why I crammed it there. All right guys, let's continue. So let's substitute them. Let's substitute. We can say x is equaling to negative b. What is b here? This is gonna be 10. There we go. Plus or minus, now square root there. Let's put the square root there. So b is gonna be 10 to the power of 2. Let's just stretch it a bit. Minus 4. What is a? A is 3, and then multiply by c, which is gonna be 2. This is all divided by 2 to the power 2 multiplied by a. What is a? A is gonna be 3. Now if we do this one here, you're gonna have the following. X is gonna be equaling to negative 10. Remember, this is negative 10. So inside here we're gonna be having let me start with the plus. When we have a plus here inside the square root, you're gonna have 76. If you put that on your calculator, over 6, and remember there are 2 now. There are 2. This one is going to be negative 10. This time around, instead of plus, remember this is plus or minus. Instead of plus, we put a negative there. Then this is going to be root 76 over 6. There we go. There we go. There we go. There we go. And then we know that there's x here. If you put this in your calculator, you're gonna come up with a negative. Let me just close here. Negative 0,214, and the other one here is gonna be, let's put this on our calculator as well. This is gonna be negative 3,116. Is it once? No, 126. 126, guys. 126. So these are x values on our turning point. Remember, a point, it has x and y, guys. A point, it has x and y. So this is the x value of that turning point. Okay, now let's continue. Let's find the y values of this turning point. So we have to create more space here, and then we have to drop down our question so that we can able to see what we are working with. Okay, let me just erase this highlight here, because we are highlighting to show the questions that we're supposed to pay attention to. All right, now guys, let's continue. Now we need to find y, the y value of this. Remember, you must substitute the x-axis, or the x values on the original. So let me write the original here so that when you scroll down we don't struggle. So let me just equate it with y. So this is going to be y. So the original, as you can see here, we have x to the power of 3 plus 5x plus 2x minus 8. Guys, this is the one that I'm talking about. It's the one that is given to us from the question, guys. Okay, from the question. Now, in order for us to find the y value of the turning point, we need to substitute these guys there. We need to substitute the x values there. So let's do it, guys. Let's do it. So let's start with the first one here, which is negative 0,214. So if you say y, okay, wherever there is x, we substitute with negative 0,214. But this x here is cubed, so we put cubed there. And then we say plus, okay, this is 5, and then it's going to be negative 0,214. There we go. And then this is going to be squared. Oh, I forgot the squared here. Okay, the squared there. It's going to be squared. There we go. And then we say plus, and then we have 2 negative 0,214. 214, and then this is minus 8. So when you put this on a calculator, you should be able to come with this following answer, which is gonna be our negative 8,21. Guys, I've already done this on my paper, so this is just for you guys to do the calculation, to explain how we solve this, guys. Okay, don't be surprised when I answer or write the answers very quickly. Okay, now let's continue. Now we can say this point here, let's call it TP1, turning point 1. Can we call it turning point 1? Turning point 1, the coordinates of the turning point 1, we have negative 0,214 for x, and then for y we have negative 8,21. Now we don't know yet whether it's maximum or minimum. All right, so I can say let's try to find the other point, or the other yeah, let's find the other point of this turning point here. All right, let's create more space, guys. Let's keep on creating more space. All right, now in order to find the other one for TP2, we need to substitute the original. Remember, this is the original. Let me just take it up a bit. Remember, we need to substitute now the other one, which is I need to open more space here. We need to substitute the other x. Remember, on this one here, we substituted this x here, negative 0,214, and then here we need to substitute negative 3,126 on the original here. So let's do it. So the original, what do we have here? We have negative 3,126. This is supposed to be cubed because we have cubed them, plus, and then we have 5 multiplied by negative 3,126, and then this is gonna be squared. Do not forget this is squared, and then plus 2, then negative 3,126 minus 8. Right, so when we find our y here, this y is gonna be 4,06. so this is our y. Now turning point number 2, let me just write 2, TP2. The coordinates of this turning point is gonna be negative 3,126, and then 4,06. Right, we don't know yet which one is maximum, which one is minimum. So it's time for us to distinguish between the two now. Remember, we were asked to distinguish between the two. If I can highlight here, let me just highlight here. We are asked to distinguish which one is maximum and which one is minimum. We already find our points. Now it's time for us to distinguish now. Distinguish meaning tell which one, show the difference. Okay, show which one is which. Okay, now before we start, let me just come here very quickly. Before we start, in order for you to know which one is the maximum, which one is the minimum, you have to derive the original formula. This one here, you have to derive this formula here twice, but then there is something that I need to show you guys. So when you derive it twice, your your d squared y over dx squared, when it's greater than 0, meaning it's gonna be positive. This means that it's a minimum. I hope you guys understand. When the second derivative of the function is greater than 0, when we substitute the turning point or the x value and you get a positive answer, that means it's a minimum. But when it's the d squared y over dx squared, it's less than 0, meaning now it's gonna be negative. It means it is maximum, guys. Okay, max. I hope you can see, guys. Okay, I hope it makes sense. Let me repeat again. Remember, we have to derive this function for the second time. Now, when we derive it, we're going to substitute the x values there. When we get the second derivative that is above 0, we must know that it's a minimum. And when you get the second derivative that is less than 0, we must know that is a maximum. So how do we do it? How do we check? Because that's what exactly what they want. So let's do the second derivative. Let's look at the first derivative. Remember, the first derivative, it was let me just take it up there a bit. The first derivative, let's go up. The first derivative is, where is it? Here's our first derivative here. Where is it? Our first derivative here, it was 3x squared plus 10 plus 2 equaling to 0. So I have to derive it. Let me just write it here so that you can able to remember. So our first derivative was 3x squared plus 10x plus 2. Yes, that was our first derivative. Now our second derivative, let's do our second derivative. Second derivative, dy squared, d squared y over d, and then x squared. Now it's gonna be 6x plus 10. So what we need to do here is to substitute. Let me just highlight here. In order for us to get the right answer, you see this x here, we need to substitute it with our turning points. This is a turning point value of x1 and the other turning point value of x2. I may put it that way. So we need to substitute those guys there on that second derivative. So let's do it, guys. I hope you can still follow through because I'm moving a lot up and down, but I'm doing this so that I can able to explain to you guys. So let's do it. Let me just open space for us. Oh yeah, let me open space for us because we really need more space. I'm gonna do it here. All right, yeah, I want to see this one. Yes, so let's do it here. All right, remember this is the first turning point, so you have to substitute this formula. Let's start with the first turning point here. So if we substitute this one here, let me just do this. If you say d squared y over x d over dx squared, and so we say 6, and wherever there is x now, we substitute with this one here, which is negative 0,214 plus 10. What is our answer? So let's see our answer. What is gonna be our answer? So our answer is gonna be 8,704. If you put this on a calculator, this is gonna be your answer. All right, guys. Now let's look at our answer. Is our answer greater than 0 or less than 0? If it's positive, remember it means minimum. So we can say minimum, meaning them. If you go to the point, the first turning point there, we can say this is a minimum turning point. Okay, you can write minimum next to it so that we can able to see. You guys see? Just write minimum next to it so that we can able to see. All right. What about the other one here? Let's do the other one. Let me just now create more space so that we can do the other one. As long as you can see the turning point number 2. So if we do the turning point number 2, d squared y over d x squared. Now this time is going to be 6. Instead of substituting the other one here, we substitute the x value of the turning point 2. Okay, I hope you guys can able to see this. This is going to be negative 3,126, then plus 10. Remember, we're substituting on this formula. So our answer, what is our answer? Our answer it's gonna give us negative 8,72. So since this is greater than, this is less than 0, remember when it's less than 0 it's maximum, so this is max. So you can go to your turning point here and write max. All right guys, so this is how you get the maximum, and this is how you distinguish between the maximum turning point and the minimum turning point. So when we mark, obviously we're gonna look at this part here, or you can rewrite them underneath, it's fine. We're gonna look at this part here. If you manage to say the turning point number 1, it's maximum. Turning point number, it's minimum, and the turning point number 2, it's maximum. It's really up to you which one is number 1, but they must be correct though. Which one should be minimum, which one should be maximum. All right guys, let's take a break, and then we're gonna be doing the point of inflection right now, because this kind of took a little bit of time. So I'm gonna pause this video, I'm gonna continue later on. All right guys, now it's time for us to do point of inflection. I hope you are ready. So point of inflection guys, what you should know about the formula, it's also the second derivative d squared y over dx squared, but this time around it's going to be equaling to 0. So this we're going to equate it to 0 now, meaning we have to find the x coordinate, and then after finding the x coordinate, that x coordinate we're going to substitute it to the original in order for us to get the point of inflection. By the way, the point of inflection is a point at which the graph is no longer increasing, it changes from increase to decrease, or vice versa. All right, let's find it now. Now we already done this second derivative, so we are fine. We can continue here and do this. We can say 6x plus 10 is equaling to 0. Remember, the second derivative is going to be equaling to 2. This is for point of inflation. I hope you guys can able to see this for that. Now we're just solving for x here. You're gonna take x to the other side, plus it's gonna be equaling to negative 10, and then x is equaling to negative 10 divided by 6, and then this is the same as let's see, we can use 2. This is the same as 5 over 3. Yes, this is the same as 5 over 3. Now this is our x value for this point of inflection. What about the y value? Remember, we must take from the original. So the original here, this is the original formula guys. Okay, f of x, let me just do it here. I think it's going to be much better this way. So it's going to be y is equal to, let's put, wherever there is x, we put negative 5 over 3, and then cubed, plus 5, then we have negative 5 over 3, Jesus man, squared, plus 2, what we have, negative 5 over 3 minus 8. This is from the original guys. We have x cubed plus 5 x squared plus 2 x minus 8. So what are we going to get here? Let me just pause to do some calculations guys. All right guys, so this is gonna be negative 56 over 27. Now your point of inflection is gonna be this, let me just say point, it's gonna be negative 5 over 3, and then this is gonna be negative 56 over 27. I think you should leave it like this. It's much easier this way guys. I hope you managed to understand how to solve 1.1 of this question here. Let's just zoom it a bit just zoom it a bit. This was the question that we're dealing with. It was 1.1, and I hope you managed to get it. This one here, it was 9 marks. So if you can do all the things that we did on this video, you will get 9 marks, which is a lot. All right guys, now let's try to do number 2 of this video. All right guys, number 1.2, 1.1.2. So this is the question that I am talking about. Let me just highlight it very quickly. There's a question here that they want us to do. Do you guys see this question here? So I'm just highlighting it so that you can be able to see. Let's read there. What is it that they want us to do there? They want us to sketch and clearly indicate the area enclosed by the graph of y is equal to x squared minus 6x plus 5. The x-axis, x is equal to 2x and x is equal to 4. Show the representative strip used to calculate the area. So here guys, they want us to calculate they want us to sketch this graph. Let me just highlight exactly what they want from us. They want us to sketch first of all. So what are we sketching? We're going to be sketching this graph here, and then obviously we need to indicate the area. So if we indicate the area, we need to indicate the area of the enclosed graph, but then the higher point and the lower point is going to be 2 and 4. These are the limits. So, and they also want us to show a strip when the representative strip when we are done. So guys, this is basically what you should do when you do this problem. All right, first of all, what type of a graph is this one, guys? This is a parabola. Do you guys see? It's a parabola. Now let's do the following. Now we know that y, let me just rewrite it here. Y is gonna be equal to x squared minus 6x plus 5. Now this one we can easily solve this one, guys. Okay, let me just find the y coordinate. When y is 0, what is x? So that's what we need to know, right? Excuse me guys, I did something here. Okay, I'm back. Sorry about that. When y is 0, what is x? Now we have to factorize it. So wherever there is y, we put 0, and then we're going to have x squared minus 6x plus 5. Now we need to factorize this, guys. So we can say, what are the factors here? I think we can able to find the factors. 0. The factors of x is x and x. The factors of 5, when you add them, they give you 6. It's 5 and 1. Since this is minus plus, it's going to be minus minus. Meaning now our x is going to be 5 and 1. Okay, so we can say this is point A. And just do this. You can say this is point A. Point A, we know that x is going to be 5 while y is 0. Point B, we know that x is going to be 1 while y is 0. Now we are fine. Now it's time for us to find the y-intercept. So the y-intercept, x is 0. When x is equal to 0, what is y, guys? What is y? So from the very same formula that you see here on top, we just substitute. Where there is x, we put 0. So we know that y is going to be equal to, just close this, it's going to be 0. Wherever there is x, we put 0 squared minus 6, 0, and then plus 5. And then we know that y is going to give us what? 5. Meaning we can say this is point C. Point C, we can say 0 and 5. All right, now since this is a parabola, remember guys, a parabola is a graph that looks like this. Sometimes it looks like that. It means it has a turning point. It has a turning point. So we need to find the turning point of this parabola. Now, in order for us to find the turning point, there is a formula for x coordinate, which is b divided by 2a. In fact, it's negative b, if I am not mistaken. Let me just double check. Yes, it is negative b. All right, so let's do it. So remember our b here. When you go back to this polynomial, to this trinomial here, we know that this is b, so it's negative. So negative 6 divided by 2. A, it's a coefficient of x squared, which is gonna be 1. So we can say x is equaling to, this is gonna be negative, negative, positive. This is gonna give us 3. Now we have to take this 3 here and substitute it to the original there. Now since we know that the original we have x squared, wherever there is x we put 3, then squared, minus 6, 3 plus 5. So your y here is gonna give us negative 4. There we go. Meaning our turning point is gonna give us 3 and negative 4. Now it's time for us to draw a graph. So let me just create more space here, a little bit of space, just a little bit. We don't need much of a space, okay? Just a little bit. All right, so our graph, let's do our y-axis and our x-axis. So this is going to be y and that is going to be x. Okay, now let's look at the coordinates. Let's use them for y. The highest point at y for y is going to be 5. So if we can say 2, 4 and 6. All right, and then we say 2, 4 and 6. And just create more space guys here, because you might need, in fact we're gonna need this space, and then here it's 0, 0, and then the highest point also x is gonna be 5. So it's 2, 4 and 6, 2, 4 and 6. So there's gonna be positive 2, this is gonna be 4, and that is gonna be 6. Positive 2, 4 and 6. Negative, let me just write them here. Negative 2, negative 4, 4. Oh, this 4 doesn't look like 4. Let's write it right. Negative 4, negative 6. What about this one here? It's going to be negative 1, negative 2, negative 4. Remember, negative 6. Remember, we are using the multiplication of 2. So let's start with point, and we just change color here so that we can able to see which point is it. Let's start with point A. So this is point A here. So point A, we have x as positive 1. You guys see, we have x as positive 5. I mean, so positive 5 and y is 0. So it's supposed to be somewhere here between 4 and 6. And then B, y, x is point B here. X supposed to be what? Supposed to be 1. So 1 is between 0 and 2, because y is 0 here. And then let's look at point C, the intercept, the y-intercept. So our x is 0, which is going to be within here, and then our y is going to be 5. So 5 is between, again, 4 and 6. So it's supposed to be somewhere here. Now let's look at the turning point. Now the turning point, x supposed to be 3. So 3 is between, if we draw a line here, this is 3, is between 2 and 4. and then -4. So this is -4. Wherever these two lines intersect, that is going to be our turning point. Now we start drawing our graph. Let's draw our graph. There we go. Trying to be linear. I don't want it to be linear. I just want it to be okay. Right, guys, this is taking its sweet time. Let me just try to do it this way, and then we turn here, we go up there. I hope you guys can see. Right, so this is our graph. The turning point is giving us a serious challenge, but this is our graph, guys. Okay, right, so you can write here point A, point B is still fine, and and TP here, that is also fine. But then remember, what did they want us to do here? They wanted to show the representative strip. Let me just use a different color, guys, for representative strip. Let me use yellow. So a representative strip should be between the area. Now I need you guys to pay attention. First of all, we need to indicate clearly the area that is enclosed. So the upper and the lower limit is going to be x equaling to 2 and x equaling to 4. And when you look at this graph here, x is equaling to 2 here. So here you draw a line to indicate your area. Here you draw a line. Let's draw a line here. There we go. And then we have 4, and then another one which is 4. You guys see? Then from here you need to draw your representative strip. Let me just change the color again. Let me use this one here. It looks very interesting. The representative strip should be between the upper and the lower limits. Let me just use blue. Okay, so you can draw a line between the upper and the lower limit, meaning between 2 and 4. And then from here you start shading. Can we shade the area? And also when you shade, you only shade the area where the upper and the lower limits are. So as you can see, I'm only shading here, guys. Do you guys see? Now let me try to zoom so that you guys can see this graph here. Let's hope you can able to see it. Can you guys see now? There we go. Now it's simple. Look, the area is between 2 and 4 because that's what they want from that question. And then the representative strip could be anywhere between these two. So I put it here with that blue line. So the blue line represents the representative strip. I hope you guys understand. Just because this is cutting at or is intersecting at 1 and 5 doesn't necessarily mean that is the area that they're looking for. They're actually looking for area between 2 and 4 on the x-axis. All right, guys, so this is done. We are finished with our our question there. I don't know what question was that. It was 1.1 point, it was 1.2.1. Now it's time for us to do 1.2.2. Let's read the question there. Can we read the question? Let's go to the highlight. Now the question goes like this: use integration to calculate the value of the enclosed area indicated in question 1.2.1. Now remember, they want us to use this what we drew here to calculate the area now, because we do have an area which is the yellow side here, but they want us now to use that to calculate the area. So let's do it, guys. So remember integration. This is how you're supposed to do it. I hope you still remember integration, guys. So when you do this one, let me just take this paper, and because we still wanna do them. Okay, now this is gonna be 1.2.2. okay, now we need to find the area. So when we use, so we're gonna have S here, and then remember we have the upper limit and the lower limit. So the upper limit from 1.2.1 is gonna be 4, and the lower limit is 2. And then here we're just gonna put the equation as it is, guys. Okay, 2x minus 6x plus 5, and then do not forget dx, meaning dx, that means that we have to differentiate. Now let's I mean, it means we have to integrate. Now let's integrate this one, guys. Let's integrate this one. So we haven't done videos on integration, but guys, when you integrate from the first principle or the standard, in fact this is a standard integration, what you do is the formula is like this: it's x and then it's n plus 1 divided by n plus 1. That's it. That's it. So let's do this one here. So if we do that, it's gonna be x, our n is what is 2 here, is 2 plus 1 divided by, oh, we are running, divide by 2 plus 1. There we go. So this is for the first one, minus. Now the second one, we have 6 here, and then we have x, it's 1 plus 1. Remember, with this is 1 there, the power, and then 1 divided by 1 plus 1. All right, and then plus. When there is no x here, if you don't have x on, or if you have a constant, you're just gonna write that constant, then you just add x. Nothing more, nothing less, guys. Simple like that. So here, what you have to write, remember, when you differentiate, usually we write c. Do not add c here because we are calculating for the area. Let me just write a here. Okay, we are calculating for the area. So this is gonna be 4, and then that is gonna be 2. So the next step that you must do here is to substitute. When you calculate for the area, guys, you have to differentiate, you have to integrate, then the first or the upper limit you substitute it, and then minus with the lower limit substitution. Here's what I mean. So the area here, if you want to get the answer, first of all, let's simplify it. This is going to be x to the power of 3 divided by 3, and then minus, this is going to be 6 divided by 2, this is going to be 3, and then it's going to be x squared plus 5x, and then we have power of 4. Right here, now the next step is to substitute. Now let's substitute to get the area. So here, let's do it. Now remember, the first bracket, we're going to substitute with the upper limit, which is going to be 4. So it's going to be 4 to the power of 3 divided by 3 minus 3. Wherever there is x, we put the upper limit, then square, which is going to be 4, plus 5, and then we have 4, and then we do this, then minus with a substitution of the lower limit. Guys, this is the formula. Please make sure that you remember it. So let's minus the very same integration with the lower limit. So this is gonna be x minus 2 cubed divided by 3. Remember, this 2 here is where we substitute x here, minus, then we have 3, and now we have another one, 2, and then this is going to be squared, and then plus, and then we have 5, and then we have 2, and then this is going to give us that. So when you put all this on your calculator, guys, if you put this on your calculator, the final answer that you're going to have is going to be it's going to give you a negative sign, but I'll tell you why. So you're going to have negative 82 over 3, which is the same as negative 27 over 333. Unit square. Don't forget unit square. Unit square. All right. Now the answer is not allowed, guys, to be negative. So rather write it as positive. But I'll tell you why you should write it as positive. Right. Let me just inform you very quickly. I just need a space here. Look, guys. Remember, let's go back to our graph. Remember, the area that you're looking for is actually on the negative side of y. If you look at the y-axis, y this side, the area here, y is negative. You guys see? So the area, if you still remember from our cubic graph, the area, let me just do this. The area of this one here, just use a different color. The area of the upper part is going to be positive, and then the area the area of the lower part is going to be negative. So if you look at this graph here, we have the lower part of y-axis, so that's why this area is negative. So the formula, in fact, we're supposed to write it like this. Let me just go back to the formula. We're supposed to write the formula. We're supposed to put negative here and negative there and negative there, so that we can have, let me just erase the equaling signs and write the negative in the right way. We're supposed to have negative, negative, negative. All right, we're supposed to have negative, 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 hey, negative. So this is equaling to that, this is equaling to that, this is equaling to that. But that's the reason why it is negative. I hope you understood, guys, and I hope the audio didn't get this step. All right, guys, now let's pause. Let's pause. We'll continue and do the last question. Okay, guys, now that we are done with the other one, how about we do number 1.3? 1.3. All right, where is my cursor here, guys? My cursor is missing. What's happening? All right, people, let's do it. 1.3. Now 1.3, let's highlight it. What exactly is it that they want from us? 1.3, they want us to calculate. I think the question goes like this: the work done on the particular object is represented by the following formula. Now here's the formula here that I hope you can see. W is equaling to integral 1, the upper limit is 1 and the lower limit is half, and 100 x dx. So let me just write it. So work done is equaling to, and then we have the integral here, and then we have the upper limit, which is 1, and the lower limit, which is half, but this is equal, this is 100 dx. Basically all we have to do here, oh, we have x here as well. All you have to do here is to differentiate, just to integrate this problem here. Remember, I did show you guys earlier on how to integrate. This is a standard integration, guys, nothing more. So before you do anything else, we need to integrate. So let's integrate here. W, so we're still gonna write 1.5. Okay, so I forgot here. We're still gonna do that. So we know that this is gonna be 100, and then we have x 1 plus 1 divided by 2, or 1 plus 1. Let me just say 1 plus 1, and then we know this is gonna be 1 and this is gonna 0 comma half. If you continue, this is gonna look like this. We're gonna have 100. What is x? What is the power here? 1 plus 1 is gonna give us x squared. Divide by this is gonna be 2. All right, do not forget to write your limits. This time you write them here because you already integrated. So let's continue. This is gonna give us 50 x squared, and then let's not forget our upper and lower limit, 1 and 0 comma 5. Now it's time for us to calculate the area, or the work done, by the way, not the area. This time around we are calculating the work done, but it's similar as if we are calculating the area. So it's gonna be as follow: 50. So wherever there is x, we're gonna put 1 squared there. Remember, the upper limit is always on the first bracket minus the lower limit, which is gonna be 50, and then we have 0.5 squared, and then let's see what's gonna be our answer. Let me create more space here so that we can be able to write our answer. So our answer here, excuse me, so our answer here is gonna be 37.5 unit square. Guys, this is how we solve the 1.3 of this question here. Let me just put it 1.3 of this question. So we are done with question 1. I hope you guys managed to follow through, and I hope I didn't make any mistake on when we're calculating. So I'm gonna pause this, and we're gonna continue with question 2. All right, so this is question 2. So what is it that they want here? On question 2.1, they want us to integrate the following in terms of x. So this is what they want us to integrate. As you can see, this is about 7 marks. So guys, you must able to do integration. But before we start, what exactly is integration? So to explain it in a very simple way, it's actually the reverse or the opposite of deriving. If we were deriving, so we must able to go back. So integration is actually that process of going back from what you've been finding the derivative of. So as you can see, we have 1 2 3 4 5 6 terms. So these terms here, you must able to know their derivatives, especially the trigonometric ratios. As for the exponent, this one here, you don't have to worry that much, because you can actually able to use the formula. There's a general formula for this one, but for this one here, you need to know the derivative, and this one also has a formula. This one is a formula. We did the formula on question 1, and then this is a trigonometric function or ratio, also has a formula, and this one here, it's a constant. So let's start. Now let's start with the first term. So the first term, before though we start with the first term, let me first try to write this. So I'll try to zoom out again to 100% so that we can have enough space. I'm gonna rewrite this question here, guys. Okay, let me write this question. Okay, all right, so let's write it. So we have s here. Let me just write the number of the question. This is 2.1, right? So we have the s here, and then open bracket. So we have 2 to the power of negative 9x plus half. There we go. And then cosec squared x minus, I hope this will make sense, minus pi over x plus x exponent negative 7 over 5 minus 15 sec 15x multiplied by tan 15x plus, I hope this is visible, guys, natural log, just plus natural log y, and then we put this, and then it's gonna be dx. So this dx basically means that we are integrating in terms of x. So dx basically means that. All right, so let's start. Let's start with the first term. Now let me put a equaling sign there. So there is a general formula for this first term. I'm gonna try to write it here so that we don't get confused. So when you are given or the general formula for exponent for integration, it's like this. So we are given integral there. Let's say you have k. Remember, k is a coefficient of the whole function, or the base in this case. So we have a, which is the base, and then we have n, and then we have x, right? So when we find the integration or the integral of this problem here, or exponent function, this is going to be k, right? And then we have a, which is the base, and x over n natural log then a. So this is the formula for integrating the exponent. So guys, now when you look at our first term here, we don't have k, so we are fine. K is actually 1. You can just say k is 1. And then what about our a? Our a, which is our base, when you look at our first term here, it's going to be 2, right? And then what about our n? Our n here is actually negative 9. And then what about that's it. This is what we have here, guys. This is this term here. All these are from the term here. So it's time for us to substitute this formula there. So our k is 1. Even if you don't write it, we are fine. And then the next step, we're gonna have a. So our a here is gonna be 2. And then what about the second one? Is we're gonna have n. Remember, n is what? Is negative 9. There we go, negative 9. Just because this negative is too much, let's in fact remove this 2 as well. Write it here, right? Negative 9. There we go. And then x, right? So from here, what do? We divide. Remember, we divide here, and then we multiply by negative, we multiply by n. We have n underneath here, but what is our n? Is negative 9 natural log, and then our base here is what? It's 2. So let me just write the n here in the right way. Our base here is gonna be 2. Don't forget, this is negative. So guys, this is how you do the integration for exponent, right? If we have the function that has an x as an exponent, this is how you do it, guys, right? So this plus c, we're gonna insert it at the end of this problem here. At the end there, we're gonna include it. So I hope you understood this one. Now let's go to the next one, plus. So this one, I need you guys to pay attention, because it's very confusing if you don't know what's happening. First of all, when it comes to trigonometric ratios, you need to know the derivatives in order for you to know the integrals. So because I've been doing this for some time, and I did this on previous videos, I already know what is the integral of this one, but I'll show you a trick that I use to find the integral of this problem here. First of all, let's go to the formula sheet, right? The formula sheet is always given to you guys on your question paper, so you don't have to worry about that. So I will slide to the formula sheet. Remember, we have half cosec squared x. Never mind about half, let's just look at cosec squared x. What is the integral of cosec squared x? So let me just zoom here so that we can able to see. This might take some time, guys, but if you really want to understand, you will give it your time. So let's look at this. So dy over dx, as you can see here, let me highlight it with red. Right, as you can see here, this one here, as you can see, dy over dx, that everything that is within this block, it's actually the derivative of this part here. So remember, when we integrate, what do? We move from this side, we are heading to the other side. Now, what were we busy trying to, what are we trying to find here? We're trying to find the integration of cosec. Remember, the integration of this one here, the cosec here, guys. Do not forget that one. That's where we are. So, and don't forget that this cosec is actually positive. So let's go. So we are moving from derivative to the original. So we are going back to the original. So if we are given negative cosec, what is our integration of cosec square? It's gonna be cot. But that cosec that we have there, it's positive. So meaning if our cosec here is negative, our cot is gonna be positive. Meaning now vice versa, if we have positive cosec, meaning the integral of that cosec is gonna be negative cot. All right, so let's go back. I hope you guys understood this one, because it's very confusing if you are not paying attention. But the nice thing about this is a video, and able to watch this over and over and over again until you understand. Okay, let me just zoom down now. So there is something that I would like to add here, guys. There's something that I like to add. I hope you will be ready to understand it. So as much as we know now, we know that the integral of cosec is going to give us a cot. Now look, the general formula for trigonometric ratios, when you're given the integral, for example, let's just use this cot here. You're going to have k, which is the coefficient of cosec squared, and then we have n, and then x. So when we differentiate here, remember, if this is positive, so we're going to have negative k, and then cot, and then we say nx over n. All right, so this is our, or plus c, this is our general formula here. But what you should know is the fact that we don't have n there. In fact, n is 1, so let's just substitute. If you look at the second term, this term here, k is what? K is equaling to half, right? And then our n, what is n? N is equaling to 1, and that's it. So all you have to do now is to substitute here. So let's do it. So we have k, remember this is gonna be k, and then we're gonna have k, which is half. There we go. Since the differentiation of cot, positive cot, it gives us negative cosec squared. So meaning the integration of cosec squared, when you go back, is going to give us negative cot x. Since we have n, what is n here? N is 1. If you divide by 1, this is going to be like that. So you don't do anything. Remember, this one, this c, you don't do it here, you don't edit here. You're going to edit at the end when you're done with almost everything there. All right, now I hope you understood, but don't worry, this one also as well, we're going to be explaining that as well. Now let's go to the next term. Now this term here, we have pi over x. This pi can confuse you guys. They inserted it on purpose so that you can be confused, because pi kind of look like x if you are looking at it in a rush. So let's do it, guys. Let's do it. I know this is gonna take a little bit of time, but I have to explain it in a way that you understand. So when we have this term here, this is the third term. When you have k multiplied by 1 over x, the integral of this one is gonna be k natural log x plus c. So only when we have 1 over x to the power of 1, Remember, only when x has the power of 1, that's where you can use this formula here. If x has the power of 2, 3, whatever the power, if it's not 1, then you don't use this one, guys. This is only, I repeat, this is used only when the x has the power of 1 on the denominator, or when it's like this, just in case you wonder when it's like this. Do you understand? The power of -1, then that's when you can use this. If it's the power of 1, it should be on the denominator. Okay, now let's continue. Now our k in this case is gonna be, our k here is what? When you look at this, it's gonna be pi. There we go. That's it. That's it. That's the only thing there. So when we integrate this one, we're gonna substitute k, which is gonna be pi. There we go. And then we integrate 1 over x, which is gonna be natural log x. And that's it. For now, we are fine with this one. So let's continue. Let us continue. Let's do the fourth term. I think this is the fourth term. 1, 2, 3, 4. Yes, this is the fourth term. Now let's do the fourth term. Now when we do the fourth term, as you can see here, let's say plus to make things easier. This is a standard integration, guys. This is a standard integration. The formula for standard integration is very simple. All you have to write is x to the power of n plus 1, then this divided by n plus 1. Simple. Now when you look at the fourth term, our n is equaling to -7 over 5. That's it. And then from here, what do? We just substitute here. So can we substitute, guys? So we can say we substitute from here. So we have x, right? And then we have n, which is -7 over 5 plus 1, right? All this is divided by -7 over 5 plus 1. There we go. That's what we did here, all right? And then let's go to the next term. This one, again, this is a trigonometric ratio. I hope you're gonna pay attention. If you couldn't understand this one, I hope this one here you're gonna understand it. As you can see, we have 15 sec 15x multiplied by tan 15x. As you can see, they do have the same angle, which is 15x, and they have a coefficient of k. Now we need to go to the formula sheet and see that on the differentiation part or derivatives, do we have sec multiplied by tan? Let's go and check, guys. Let's go and check. All right, so when we let me zoom it, do we have sec multiplied by tan? If we can look at this, guys, if you can look at this, we do have sec multiplied by tan. Do you guys see? I hope you can see, guys. I hope you can see. Remember, the aim here is to go back. When you integrate, we are going back. So we have sec multiplied by tan. We do have sec multiplied by tan here. So what is the integral of sec multiplied by tan? It's actually sec. So whenever you see sec x multiplied by tan x, the integral is going to be sec x. So let's go and do it this side. I hope you guys manage to see that one, guys. It's a bit challenging. I know it's a bit challenging, but we need to do those examples. Now it's time for us to use the general formula for integration. So when we have the integration of k, remember k is a coefficient of those integration, sec, then we have n multiplied by tan, then nx. The integration here is going to be simple, really. Remember, it's going to be k, right? And then what is it? We did check on the formula sheet what is sec nx multiplied by tan nx. We know that it's going to give us sec nx, but since we have n, we divided by n. Now it's time for us to write the k. What is k in this case? Remember, it's a coefficient of this integral here, so it's going to be 15, right? All right, what about n? What is n in this case? If you look at the angle here, this is remember, n is a coefficient of x, so you have 15x and 15x, so also n is 15. So when we substitute these values here, the k and the n here, we're gonna be having 15k and then sec 15x divided by, oh, what's happening here, divide by 15, right? Remember, n is also 15, so this is for this one here, the whole of this, the long one here. And then what about this remaining, the remaining one there? Remember, the c we're gonna add it later. What about the remaining one there? Let's erase this. I know, guys, this takes time, but we have to do it. What about the remaining term here? So we have plus. Okay, let me just open up a bit the space a bit here. Now plus, so we have natural log y. Now guys, as you can see, we are integrating in terms of x, so we do not have x here, so this makes it to be a constant. Now remember, with differentiation, when we have a constant, it's 0, but this is integration, so when we have a constant, we just introduce whatever we are integrating in terms of. So in this case here, we are integrating in terms of x, so we just introduce x, then natural log y. Then remember, because we are integrating, you must add plus c, so we are done here. So when you do this, the s, this s here and this dx, they fall out to show that we integrated. So now it's time for us to simplify this problem. Now let's look at our first term. Remember, guys, what you need to know is that never leave your answer with a negative exponent. So how are we going to do this? If we want to change this exponent to positive, remember, we have to take the base to the denominator. So we're going to have 1 over, let's not forget this is minus, by the way, so we're going to have 1 over minus, let's just put 9 here, multiply by, now this is going to be 2, now since it's down here, x to the power of 9, 2 to the power of 9x, and then natural log 2. Okay, it looks a bit strange, but this is good, and then here we're gonna have minus because we have this negative here, so we multiply by half, so we're gonna have cot x divided by 2, and this one here is fine, we're gonna write it as it is. We're gonna have pi natural log x. And then this one here, what is, okay, first of all, let's start here. We're gonna have negative, since we have negative here, do not forget, and then we're gonna have x, but then what is negative 7 over 5 plus 1? What do we get here? We're going to get 5, negative 5 to the power of let me see if I'm still correct, to the power of I made a mistake, guys, not negative 5, it's actually, put it in your calculator, it's 2 over negative 2 to the power of 5, meaning now here we are divided by negative, we are divided by 2 over 5. I hope you guys can able to see that one. Minus, so this 15 and that 15, they will divide each other and give you 1, so you're gonna be left with sec 15x plus, there's nothing you can do here, this one is just natural log y plus c. Now remember guys, you cannot leave an answer, just like I said, you cannot leave your answer in a negative exponent, and also the fraction is exponent here. So we do have negative here, so this is gonna be 1 over, let's just do this, now this is gonna be 9 multiplied by 2 to the power of 9 x natural log 2 minus cot x. So these ones are fine, as we are writing them, they are actually fine. And then we have natural log x minus, so we need to deal with this one, guys. So when it's like this, if you put it in your calculator, you're gonna, this 5 is gonna come in the numerator, right? But this 2 is gonna remain in the denominator. Then remember, we try to get rid of the negative exponent, so this is gonna be x, and then we have positive 2 over 5 as exponent minus sec 15x plus x natural log y plus c. All right, so you can leave it like this, guys, it's still fine. But if you want to continue to change this into sats, so you have to continue like that, negative 1 over, now we have 9 to the power of 2, 9 x natural log 2 minus cot x over 2, and then minus pi natural log x minus 5. So this one here is going to be 2, and then square root, in fact fifth root x to the power of 2 minus sec 15x plus x natural log y plus c. So this is the final answer, guys. I hope you managed to understand this one, guys. When we mark it, this is gonna be 1 2 3 4 5 6 7. Remember, this is 7 marks. I know it took time as I was explaining it, but it shouldn't be taking that time for you guys, because as for you, you already know things that I've been explaining, I assume. So guys, let's just pause and let's do the next question after. All right guys, now it's time for us to do 2.2. so let me just highlight 2.2. This is a 2.2 here. They want us to simplify this problem here. So I hope you can able to see what's happening there. This time around, this is very simple, but as you can see, as long as you see this s here, it means we need to integrate as well, but we need to simplify it, so way much better. So now let me just write it 2.2, and I hope the space is going to be enough here. So they want us to integrate to simplify this problem. We have 2 minus cos x over sine squared x, and then dx. Guys, the minute you see dx, basically it means you should integrate. So the first step here is to simplify first, guys. You cannot integrate this without simplifying. So how are we gonna simplify this problem? So I would say to you, while you're simplifying, this s must remain there and this dx must remain there, because we are not integrating yet. So we're still simplifying, the s here must remain there. All right, so you can do this. You see 2, since they do have, since this 2 and this negative cos x, they have the same denominator, you can separate them like that and write 2x sine to the power of 2, sine x to the power of 2 minus, and then we have cos x. Remember, it's the same thing here, guys, right? So I can write this sine x squared like this. I can say sine x multiplied by sine x. Guys, by the way, this is the same as sine x multiplied by sine x is the same as sine x squared. Here, guys, name is the same. I decided to separate it or to dismantle it. Okay, so don't get confused. I have a reason why I'm doing it like that. Okay, so for the fact that we still have this s, it means that you should also write dx there. We're still integrating. So here we're gonna use what you call the inverse. What is the inverse of sine? All right, if we have 1 over sine, what is the inverse there? If you still remember, the inverse of 1 over sine is gonna be cosec x. So since this is squared and that is multiplied by 2, so we can say 2 cosec squared x, right? And then here, what do we have here? Minus. Yeah, we do have minus. What do we have here? If we say cos over sine, let me just erase this. Oh, by the way, just in case you don't know where the inverses are coming from, there is a video about inverses here. Go and watch the video about inverses, guys. I hope you did watch them, or I hope you understand where the inverses are coming from. But if you don't, go and watch that video. I explain the type of inverses there. Okay, now let's go. Now let's look at this here. We have what you call quotient identities. So cos x over sine x is gonna give you cot, right, x. So as you can see here, let me just highlight these two here. Just highlight this cos here and that sine here. They can give you the cot. You guys see, they can give you the cot here. So we can write it as a cot. Let's just write cot x. But then what are we left with here? We are left with 1 over sine x. This sine here, there is 1 here multiplied by 1, by the way. So this 1 over sine x, what are we gonna have? We're gonna have cosec x. So we can say multiply by cosec x. So this is still multiplied by dx, right? Let me just put this on our bracket there. Okay, right, so this is what we have. We are not done yet. Now it's time for us to do the integration. Remember, guys, whenever you come across the trigonometric ratio on integration, you need to check your formula sheet. So let's go to the formula sheet, guys. Can we go to the formula sheet and check let's start with this one. We have 2 cosec squared. Now let's see what is cosec squared on our formula sheet. Where is it? Let me just drop it down here. All right, now let's check, guys. As you can see, we are moving this way. Do we have cosec squared? Of course we do have a cosec squared here. So cosec squared, negative cosec squared, it gives us cot when we go that side. So this side, do we have a negative cosec squared, or we only have positive cosec squared? So how are we gonna do it? So meaning when you integrate this one here, this is gonna give us negative 2 cot x. Remember, we divide by n, but our n here is 1, so we don't really have to do it here. Now let's check this one here. Now let's check this one. We have negative, we just write the negative here. We have negative cot multiplied by cosec. Do we have cot multiplied by cosec. Let's go to the formula sheet. We do have cot multiplied by cosec. Do you see, guys? Cot multiplied by cosec. So the negative is going to give us the positive. So we are fine. We actually have the negative cosec multiplied by cot, or the other way around, but it doesn't matter, they're multiplied. So they give us a positive cosec. So let's do it, guys. So meaning now, if it's negative, this is going to be positive. Let's do this. It's going to be positive cosec x. There we go. Now we can say plus c. Guys, this is simplified enough like this. You can rewrite it like this if you want to. Cosec x minus 2 cot x plus c. This is simplified enough, guys. It is simplified enough if you want to what is this? If you want to continue, I don't think you can continue here. This is actually simplified enough. Alright, guys, I hope you understood. As you can see, I hope you can see the pattern here. Whenever you integrate the trigonometric ratios, sometimes it requires you to go to the formula sheet and check whether you can able to integrate straight from the formula sheet. So on the formula sheet, you look at your dy over dx and you go back, and then if it's there, then you can go back. Guys, let me pause here and we'll do the following question. Alright, guys, let's do number 2.3. 2.3, what is it that they want here? Now, if let me highlight this question here. 2.3, here's the 2.3. They say expand square root x plus h to only 3 terms using the binomial theorem. So the nice thing about this is that we already done the binomial theorem on this channel. So I will put the video after we are done here where to actually go and do the binomial theorem or learn about the binomial theorem. So first of all, we are given the following here. We have root, and then we have x plus h, and then you need to change this, guys. How do you change this? So this is how you change it. This is the same as x plus h. How do you change the square root into exponent? It's gonna be half. There we go. So it's gonna be half. So this is our formula that you're gonna use when you use the binomial theorem. Now, usually, here's what I inform people to do. Rather, first write the binomial theorem equation when you expand. Alright, so basically it's like this. So the first term, remember they want us to expand to 3 terms. So the first term is very simple. It's x to the power of n. Simple. And the second term now is going to be different. It's going to be, it's more like you derive, it's going to be n, and then it's going to be x to the power of n minus 1 multiplied by h. There we go. That is the second term. Now the third term is going to be a bit complex, but not really. It's going to be n, and then we have n minus 1. Remember, you just multiply by the derivatives here. And then we have x to the power of n minus 2, and then h squared, and then 2 factorial. You guys see? So that's it. So we are fine here. This one was not that much of a challenge. We have 1, 2, 3 terms. Guys, if you don't know how is this came about or how to use these formulas, there is a video there where I do or try to explain this equation here. By the way, this equation that is not there on the formula sheet, so you need to know it by heart. So this video, I would say go and watch it. It's about binomial theorem, and also there are problems where I solve the expansion and differentiate using binomial theorem. Go and watch those videos there. Okay, now it's time for us to substitute. Remember, n here, let me just put it this way, n is equaling to half. So wherever there is n, we just substitute with half. So let's do it here. So we know that the one that is given to us is x plus h to the power of half, this one here. So it's going to be equaling to, it's time for us to equate this. So we do have x, but what is n? It's going to be half. So we are fine. Plus, okay, so this time we're going to be half multiplied by, just do it this way, it's going to be half multiplied by x minus x to the power of n minus x to the power of n, x to the power of n, which is half, guys, x to the power of n, which is half, minus 1 multiplied by h. That is our second term. I hope you guys can see, because it can be confusing. Plus, now let's look at this one here. So what is our n? N is going to be half multiplied by, this is open bracket, half minus 1, remember, minus 1 close bracket, and then factorial 2 factorial, guys, okay, and then we're gonna have x, and then what is n? And remember, it's half minus 2 and h to the power of 2. Now the only thing that is left here is for us to use our calculator. So if you use our calculator, this is going to be x to the power of half. There we go. Plus. So this is going to be 1 over 2. So we can say x. What is half minus 1? We're going to have negative over 1 over 2. Right? Then remember that we have 2 here. 1 multiplied by half. So this is going to be half. Multiplied by h. Let's not forget this h here. Okay, now let's go to the third term. Now the third term, I would advise you to use your calculator. All this, see all this thing that I highlighted here, put it in your calculator. All this part that I highlighted there, put it in your calculator. By the way, guys, factorial is very simple. You must press, let me check on my calculator very quickly. You must press shift, then you press x to the power of -1, so you can able to find this icon here, or this factorial symbol here on your calculator. I hope you understand. So when I put this on my calculator, what do I get? I'm gonna get negative. Remember, this is gonna be negative. Let me see. Yeah, this is gonna be negative. I said positive, but it's negative. What did I do? Yes, this is gonna be negative. It's gonna be negative 1 over 8. 1 over 8. So let me just say 1 over 8. Just put 8 here. There's 1, because this one is gonna multiply this here. So here we're gonna be left with x to the power of, what is 1 over 2 minus 2. What is gonna be our exponent? It's gonna be minus 3 over 2, and then multiplied by h to the power of 2. Right, so this is our answer. But remember, never leave your answer like this. Make sure that you leave it in a sub form. So this one here, we can do this. You can see square root x, and this one here, we need to take this negative 1 over 2. You need to make it positive. You have to take the base, which is x, to the numerator. So when you do that, you're going to be left with h, and then you're going to have 2, and then you're going to have x. Since it was negative, now it's going to be positive half, exponent half, okay, minus. So here also we're going to be left with only h squared here, and then divide by 8, and and then we have this x here to the power of negative 3 over 2. This time, if it's gonna be on the denominator, it's gonna be 3 over 2. Remember guys, we cannot leave them like this, so leave them in a sub form. So you know this is gonna be root x, and then that is gonna be plus h over 2, and then square root x minus h squared over 8. Create more space guys, and create more space, minus over 8, and then we have root x to the power of 3. By the way, this was about how many marks? 3 marks. I know it looks long, but it's really not that long. It's because I'm explaining, hence it looks and seems to be taking too long. Alright guys, this is the question for 2.3. I hope you managed to understand. So I'm gonna pause this so that you can do the last question, or the second last question, which is 2.4. all right, okay people, let's do 2.4. now 2.4, what is it that they want us to do? Now let's look at 2.4. 2.4, here it is, they want us to differentiate the following by using the quotient rule. Nice thing about this is that we already made videos on quotient rule. I will show you where to click to watch those videos. And the nice thing again is that if you manage to watch these quotient rule videos, it did something similar to this. Anyway, let's just do it guys, let's just do it. So the 2.4, right? 2.4, we have y is equaling to tan x. So this one here, we know we can do it without using the quotient rule, but we are being instructed guys to use the quotient rule. So follow the instruction. If you don't follow the instruction, you're not gonna get marks. So how are you gonna do this one? We need to change this so that it can be quotient. So meaning we have to have some fraction here. So we can do the fraction here if we say y, let me write it here, y is equaling to, what is the inverse of tan? Remember tan x, the inverse of tan is 1 over cot. Yes, that is the inverse. These are the reciprocals guys. I did already put the videos here. If you don't understand the reciprocals or the inverses, go and watch that video there. I did explain some of them there. Okay, now that's how you're gonna able to do this problem here. So let's change that tan into its inverse. So it's gonna be 1 over cot x. Right, so we have this. All right, so now we can start selecting the f of x and the g of x. Remember guys, when you use the quotient rule, one formula must be one function in fact must be f of x, and the other one must be g of x. So what's so nice about this is that the one on the numerator, which is 1 in this case, must be f of x, and the one on the denominator must be g of x. So let me just do it here. So f of x is gonna be 1 because it's on the numerator, and then g of x is gonna be cot x. So we need to find the derivatives of these two. I'm gonna use the red pen for derivatives so that you can able to see them. Now let's do it. So the derivative of f of x, which is f of x prime, is gonna give us 0. It's 0 because, do not forget, this is a standard derivative, and this is also a constant. If we have a constant, the answer is 0. Remember, we are differentiating with respect to x. There's no x here, hence this is 0. If you so happen that you want to understand it much better, I have a video that I made there about standard derivative. Go and watch it, and then maybe you're able to understand what's happening here. Okay, now let's continue guys. Let's continue. Let's derive g of x. Now if you find the g of x prime, or the derivative of g of x. Remember the derivative of g of x, which is cot x. What is the derivative of cot x? It's gonna be negative cosec squared x. Guys, if you're not so sure, these are there on your formula sheet. Let us go to the formula sheet and see what is the derivative of cot x. Let's see. Here's our formula sheet here. Here's our formula sheet. So you see, guys, the derivative. Now this time around we are going this direction. Let me use a black pen this time. This time around we are moving to this direction. So it's gonna be what? The derivative. Remember, we're finding a dy over dx. Derivative of cot is gonna be negative cosec squared. All right, so this is what I wrote there. Let me see. Is that what I wrote? Let me just take this one down here. If it so happen that you don't remember, guys, it's fine. You can always use the formula sheet. Yes, negative cosec x, cosec squared x. Right, so let's continue. Remember this, we must be able to see this question here. Okay, now with what we just did here, it's time for us to use our quotient rule formula. So let's do it. So we have dy over dx. This is a formula for quotient rule, guys. So the formula goes like this: the derivative of f of x, which is f of x prime. We need space. You're gonna need more space here, guys. Let me just create more space, which is f of x prime multiplied by g of x minus, always minus, guys, right? The derivative, oh, now this time is not a derivative, it's f of x multiplied by the derivative of g of x, divide by, this is divided by, oh yeah, this line is not right. Let's do it. Okay, this is divided by g of x squared. So we already know what the derivative of f of x is and the g of x, and also we know what is the derivative of g of x and f of x. We know those things because we already done them here. All you have to do now is just substitute dy over dx. Let's do it. Now, what is the derivative of f of x? As you can see, this is going to be 0, the red one here, multiplied by g of x. What is our g of x? It's going to be cot x minus. Now, when we minus, now what is f of x? F of x is going to be 1 multiplied by the derivative of g of x. So the derivative of g of x, the red one here, is going to be negative cosec squared x. So negative cosec squared x. There we go. Divided by, let's not forget, divided by g of x squared. So what is our g of x? Our g of x here is cot. So it's going to be cot x squared. Now let's simplify here. Let's continue simplifying, guys. Dx, dy over dx. So the first term here is going to be 0. 0 multiplied by cos x is going to, cot x is going to be 0. Negative 1 multiplied by negative cosec squared x is going to be positive cosec squared x, divided by cot. We have cot here x squared. Right, so from here, guys, we can able to solve this problem. Now we have to simplify it, guys. We have to simplify it. Remember, when we do the direct derivative of tan x, it's actually cosec squared. So we need to make sure that we leave it as a cosec squared. So the best way of doing this, we can say dy. Now we are just simplifying, guys. Okay, dy over dx. We know that cosec. Can I do this? Cosec squared x. This line here, this right is divided by cot squared x. All right, so we have to do it, guys, even though it's gonna be taking that long, but we have to. So we know that we can write cosec as 1 over sine x squared. This is an inverse, by the way. And then we can also write cot. Remember, this is a quotient identity, which is going to be cos squared x over sine squared x. Right, now we are continuing, guys. I know this is going to take a little bit of time, but we have to do it. So dy over dx. Oh, I hope the audio is not disturbed there. All right, so we have 1 over sine squared x. Then we change this division to multiplication. The numerator become a denominator, and the denominator become a numerator this side. So it's going to have sine x squared divided by sine squared x divided by cos squared x. So this sine and that sine are going to divide each other, and you're going to be left with dy over dx is equal to 1 over cos squared x. So what is the inverse of 1 over cos squared? X is going to be sec squared x. Guys, this is how you do this one here, which it was our number 4 on our question, which is this one here, guys. This was y is equal to tan x. So this is how you do it, my good people. By the way, the formula for quotient rule, this one here, just make it 100%, guys. The formula for quotient rule, let me just where is it? Yeah, the formula for quotient rule, this one here, let me highlight it. This one here, guys, this one here, I made a video on it, so you can go and watch the video here at the corner. Let me just show you here at the corner, guys. Go and watch that video. And also that formula appears on the formula sheet. It's just that they don't use f of x and g of x. They actually use different u and v. So let me show you where is it. So this is it here, guys, on the formula sheet. I know this is wasting your time, but you need to know this is it. They use this is a formula for quotient rule on the formula sheet. So I prefer to use f of x and g of x, but you can also use this one as well. All right, guys, I hope this helped you to understand. It's time for us to pause, so let's pause and let's do the next question, which is gonna be 2.5. all right, guys, we are back now. This is gonna be 2.5. Is the last question on question 2 of this question paper. Now, what do they want us to do here? Let's highlight the question. They want us to differentiate the following terms, in terms of x. And then this is a question that they have for us to differentiate. So I hope you guys can able to see it as I'm highlighting it. Just remove the highlighter there and let's start. So this is going to be 2.5. Now let's rewrite this question here. Y is equal to 1 over 3 to the power of, let me zoom it, to the power of 5, guys. Okay, to the power of 5. Let's just check. Yes, it's going to be 3 to the power of 5. Okay, all right, so let's zoom it down. 3 to the power of 5, negative 5x, by the way. Negative 5x plus, what do we have here? We have cos 2x over sine x plus cos x, and then this is equal to plus natural log pi. Guys, this pi, they know, guys, okay, this is a trick. They know that pi sometimes looks like x, especially when you're in a hurry. So take your time whenever you analyze these questions, because you might end up making a mistake here. Now, before we differentiate, remember guys, we need to put everything in a standard form, meaning we need to simplify. If we have to simplify, we need to put everything in standard form. So this one here, we need to take this 3 to the power of negative 5x to the numerator. So when you do that, it's going to be positive 5. So the power is going to be changing to be positive. And this one here needs to be simplified, guys. So this one is the one that is going to make us take a little bit of time. So if you can look at this one, guys, this is a double angle identity. So we can change this one like this. We can say cos, okay, x squared minus sine squared x divided by sine x plus cos x plus natural log pi. As long as we're simplifying, we are not gonna do anything with the other terms. So we still need to simplify. Guys, if you don't know where this is coming from, the cos squared x minus sine squared x, basically this is a double angle identity for cos. So you can go to this video here. I explain them way much better here. In fact, I derive them from the scratch. So go and watch that video. All right, so let's continue. This is gonna continue, and we're gonna continue, and we're gonna write 3 to the power of x, 5x, and then let's look at the numerator here. This is the difference of two squares, guys. Do you guys see? So how are you gonna write this? We can write it like this. We can say cos x minus sine x, right? And then on the other bracket, it's gonna be cos x plus sine x divided by, okay, divided by sine x plus cos x plus natural log pi. All right, guys, now let's look at this here. We have sine x plus cos. We also have sine x plus cos, even though they are swapped, but it's one and the same thing. This and that can divide each other, and then you're going to be left with the following, which is going to be 3 5 to the power of 5x plus, this time around we're left with cos. If we remove the bracket, it's going to be cos x minus sine x, then plus natural log x. So when it's like this, now we can differentiate. When it's like this, now we can differentiate. We can find dy over dx. All right, let's continue, guys. How many marks was this? This was 4 marks. All right. So remember, when we differentiate exponent, the general formula here, we know that y is equaling to a, and then we have n as a coefficient and x. And then when you find the dy over dx of this, it's gonna give us what? You're gonna write it as n, yes, it's gonna be n, and then it's gonna be a, and then it's gonna be n, and to the power, it's gonna be a and power n multiplied by x, and then multiplied by natural log a. So this is a general formula for differentiation, guys. I know we have done integration. Don't get confused here, guys. I hope you can able to see the difference. Now a n, what is n here? Our n on this one here is gonna be 5. Remember 5 here, and then our a, what is a, which is our base? Our a is 3. That's all we need here. So we just substitute everything here. So we're gonna have 5 remember this is n, multiplied by what is our, let me try to sit the right way, what is our a, which is gonna be 3, okay, and then n, it's also 5, and then x multiplied by natural log, and then a, which is our base, which is gonna be 3. That's it. And then we, oh, by the way, if it so happen that you need to learn more about this integration, this differentiation, go to this video here, go and watch this video, guys. I explain it way much better, and how to use that formula. Okay, now let's look at the following here. We have cos. What is the differentiation of cos? Guys, the differentiation of cos is going to be negative sine x. That's it. And then the differentiation of sine, this one here, is going to be positive cos. But since we have negative, so it's going to be positive. It's going to be negative cos. Now what about, oh, I almost made a mistake. You see this trick here, it almost got me, guys. This is not x, by the way. This is what? This is pi. This is pi. Be very, very careful, guys. They knew that if they put pi as you continue here, you're going to make a mistake and put x. I'm glad I made this mistake so that you're going to be alert when you write your exam or test. All right, so this one here is going to be what? Remember, we are differentiating in terms of x. We do not have x here. This is a constant, so this is going to give us 0. Just in case you're not so sure, go to this video here, go and watch this video about the standard derivative. Okay, guys, basically this is how you do this problem here. This is question 2, and it is complete. I hope you guys managed to understand, and I hope I didn't make any mistake. But if I did make a mistake, do not forget to comment and ask. If there's something you don't understand, also comment. But if you find this useful and you manage to watch the whole of it, don't forget to hit the like button. If you haven't subscribed, subscribe to the channel, because I'm going to do question 3 after here. By the way, there is a timestamp. If it so happen that you don't want to do, let's say for example, you want to jump straight from this video and watch maybe where I solve 3.4, there is a timestamp below on that video that you're watching. Click on that timestamp, you will see that I allocated to these videos according to the questions. All right, let's continue. Let's start with this question here, which is 3.1 on question 3. Okay, now let's read this problem. But what kind of a problem is this one, guys? This is a weight problem. As you can see, this question here, you are given the statement. So let's try to analyze the statement and try to solve it. So what we have here, they say the breadth of a rectangular field is 7 meters less than the length. All right, and then they say the area of the rectangular field is 500 millimeters square. Each side of the rectangular field is then increased by 3 meters. All right, so guys, it's time for us to analyze this. So what we have here, we have the breadth of the rectangular field, which is 7 meters less than the length. Let's stop here and let's try to analyze this. So we have the rectangular field. Let's start by drawing the rectangular field. So let's say this is your rectangular field, and then the breadth, let's say this is the breadth here. All right, so the breadth of this rectangular field, it is 7 meters less, so less than the length. So let's say this one is the length. So the length, we can say the length is x. Let's just write it here. Let's say length is equaling to x, because we don't know what length is. And then let's go back there, and then they say the breadth of the rectangular field is 7 meters less than the length. So if the length is x, for example, if the length is x, the breadth is gonna be 7 meters less. All right, I need to erase this, guys. This means that our rectangular, the breadth is the shortest side because it's 7 meters less. Okay, right, let's just do it this way. Let's do it this way. I hope it's gonna look okay. Okay, but as long as you can manage to do it in this manner, guys. Okay, all right. Okay, let's continue. So this is what you should write here. Now we also given the area. They say the area of the rectangular field is 500 meters squared. So guys, we know that the area of the field or of the rectangular, usually it's let me just write it here. Area is equaling to length multiplied by the breadth. Okay, we know the length is x and the breadth is x minus 7, so we know that. Then let's continue and read the last part of this paragraph. They say each side of the rectangular field is then increased by 3 meters. Now they want you to determine the value. Let me highlight this, the question. The actual question here, they want you to determine the value of the new area. Basically, they say when each side is increased by 3, what is the value of that area? Remember, before it was increased by 3, the value of the area is 500. Then after, the value of the area is what? That's basically what they are asking there. So this is before we increase each side by 3. So now let's substitute here. We're gonna use the area formula to simplify or to get our side here. Now let's start. We know that area is gonna be 500 meters squared. And then what about length? Remember area is length multiplied by breadth. So length, we can say our length is x. There we go. And then what about the breadth? Breadth is x minus 7. So remember they are multiplying each other here, so you can say x minus 7 here. All right, I hope you guys can see. So from here, guys, we have a function. Do you guys see? We can multiply by x here. Let's just do this. 500. We can say x multiplied by x. We have x squared minus x multiplied by -7. We're gonna have -7x. So what we do here, we're gonna take this 500 that side. We have 0, and then 500. Oh, sorry, not 500, guys. Excuse me. Then we have 0, then we have x squared minus 7x minus 500. As you can see, this now is in it's a trinomial. This is a trinomial, guys. Right, now we need to factorize this. As you can see, this is a big number. We have a 7 here, we have a big number here. The best way of doing this, guys, is to use the quadratic formula. So let's use it. So we have x is going to be equaling to negative b plus or minus. Remember the formula of quadratic, guys, is there on your formula sheet, just in case you're not so sure. And b squared minus 4a over 2a. Okay, over 2a. All right, so this is our quadratic formula. Now we need to know what is b, what is c, and what is a. So the a is a coefficient of let me just write it here. The a, let me write it on top here, guys. We have enough space. The a is the coefficient of x squared, which is 1 there, and then the b is a coefficient of x, which is going to be -7. Remember, we're taking it from this one here, and then the c is the constant, which is -500. Now let's start. So let's start substituting here. Right, so if we substitute here, this is going to be negative, but what is b? Remember, b is -7 here. Do not forget, guys. So we put in -7. There we go. Right, plus or minus, then square root. Okay, and then we have b squared, meaning we want to have -7 squared. I hope you guys can see. And then minus and then 4, and then multiply by a. What is our a? Let me just take it up a bit so that you can see, or take it down a bit. Our a is going to be 1. It's a coefficient of x squared. So this is going to be 1 multiplied by c. What is our c? Our c is a coefficient of, in fact, it's not a coefficient, it's usually a constant, which is 5, negative 500. Now we divide here. Let me create space here. Now we start dividing. All right, let's divide. We're gonna have 2. We're gonna have 2 and then multiply by a. Remember, a is 1, the coefficient of x squared. Right. So this is your this is after substituting, guys. Right. Remember, I know this takes time, guys, but if you really want to understand, you better watch the video. All right, let's continue. Now we have negative multiplied by negative. This is gonna give us positive 7. Then we're gonna have plus or minus. But let me do it this way. Let's do it this way. This is plus or minus. How about we start with plus? Okay, so if we start with plus, this is gonna give us inside the bracket there, we're gonna have, inside the root there, we're gonna have 2049 divided by 2 multiplied by 1, which is gonna be 2. So this is when we put plus here. What about when we have negative? So let's do it. When we have negative, it's gonna be 7 minus this time around, and then we have 2049 over 2. Remember, this is minus because there we have minus. So let's create more space, guys. More space, because we need to be able to solve this. Let me just take this question below so that you can be able to see it as we are solving it. Okay, now let's see what is our x here. So when we have a positive, our x is gonna give us let's just insert this on our calculator. So I'm gonna pause here so that I can put it in our calculator. Alright, guys, so for this one here, we gonna, if you put this on a calculator, you're gonna get 26,133. So for the other one where we have negative here, when we have negative, it's gonna be negative 19,133. As you guys know, we are calculating for the distance. We don't have we are calculating for a distance. We don't have negative distance, guys. Remember, the length cannot be negative. So this one is invalid. All right. So the right one is this one here. So x, which is the length, let's go up. X, which is equal to the length. So our length is gonna be 26.11133 meters. Let's not forget meters there. So what about our breadth? What about our breadth? So remember, breadth is equal to, or this I can say is equal to length. Okay, breadth, remember, it's b and then it's x minus 7. Let's go back and double check again. Remember, breadth is this one here, guys. As you can see, it's bx minus 7. So let's go and do it then. So we know that x, our length, is going to be 26. Going to be 26.133, then minus 7. So what is it that you're going to get? You're going to get 19,133 meters. So this is the length of the breadth here. So the length of the what is this? What do we call it? actually is the length, guys. Okay, this is the length, which is 26, and then this one is the breadth. Okay, I hope this is not confusing for you. So we are done finding the length and the breadth. Now let's see the actual question. Now the question says you must determine the new area when each side of the triangle is increased by 3 meters. So we managed to get to those both sides, but we must increase both of them with 3 meters. Okay, let me just take this question down here. Okay, all right, so let's do it. So we know that area, the formula is still the same, guys. Okay, the formula is still the same. Let me just erase this. We need to write it up there. The length, remember, x is equaling to the length. All right, so the formula for area is length multiplied by the breadth, right? But remember, these sides, they are added by 3 meters now, so we can say the length, what is our length, which is 26 comma 133. Remember, we are adding it or increasing it with 3 meters, so we're gonna add 3. Then what we do, we multiply, and then we multiply by the breadth. So the breadth is gonna be 19,133. But remember, they said each side, meaning both of them, we wanna add by 3. Then you just put this on your calculator and let's see if you can get the right answer. So the right answer here, if you put this on a calculator, it's going to give you 644,8 meters squared. So this is a new area when we did add the both sides with 3 meters. Guys, this was question 1 for this was question 3.1. So we're gonna be doing question 3.2 after we return from here. Okay guys, so right now we're gonna be doing question 3.2. Let me just erase the highlighter here. So 3.2, let me highlight it for you guys. We'll be doing this question here. This one is really not that difficult, guys. They just want you to make G subject of the formula there. As you can see, I hope you can see this. There is G here. Here is G here, guys. There is G. But let me try to zoom it so that you can able to see G. Let's zoom in. Let me show you G, guys. G. Do you see G? Let me zoom in again. Maybe you will see. If I keep on zooming in, there is G here, guys. Do you see? G is with V. So I hope you can able to zoom in and see. Right, guys. So this is G. So this is what they want us to make such a formula. So let me zoom down. Let me zoom down so that you can have space to write. There we go. Oh, what happened here? There we go. Let me just take it here. Okay, guys, let's write now. Let's write. Right, let me rewrite this question so that you can able to see exactly what you're dealing with. So this question here, which is 3.2. Okay, we have I, then open bracket, and let me just do the nice thing. Let me be nice. Open bracket, and we have e to the power of this is G V over CT plus 1, and then this is equaling to J. So we need to make this G subject formula, guys. This one here, subject formula. So the first thing that you must do here, guys, try to divide with I here, so that you can have this, remove this bracket. So if we divide with this I, we're gonna have I, we're gonna have E, we're gonna be left with this E here, and then we have G V over CT plus 1, and then plus 1, and then we have J divided by I. There we go. Then from here we can take this one to the other side, transpose it. So we're gonna be left with only G V over CT, and then we have J. Let's go back. Then we have J over I minus. Remember, if you take 1 to the other side, it's going to be 1 minus 1. So from here, we can introduce the natural log. I think we should introduce the natural log, but you can also introduce the standard logs. But let's introduce the natural log because of this thing. So if we introduce the natural log here, we're going to have natural log, then we have exponent GV over CT. This, what you do on the left hand side, you must do on the right hand side, guys. We also need to introduce the natural log here. Then we're gonna have J over I minus 1. There we go. So we have to use the rule from logs. We take this to the other side. Remember this rule here. Let me just write it on this side, guys, so that you can remember this rule from logs. When we have log, let's say we have to the log base 10 to the power of 2, we can take this 2 to the other side, which is going to be 2 log x. This is the same rule. It also applies on the natural logs, guys, the Neperian logs, by the way. So if we have log, let's say a squared, you can also write it like that. You can see, you take these 2 here, and then you have 2 natural log a. Guys, natural logs and the standard logs, they are all the same. They have the same principles. They might have different bases, but they have the same principle, guys. So let's take this exponent to the other side. So when we do that, this is going to be GV over CT. Right, so we left with natural log e. Then this one, this side, we don't do anything. It's fine like that. So this is going to be natural log. And then we have J over I minus 1. There we go. There we go. So I need to create more space, guys. Let's create more space so that we can continue and do this one here. Okay. Now, there's something that you need to know about natural logs. When you have natural log, then E, the answer is 1. This is similar with log base 10, 10. The answer is 1 because the base of natural log is E, right? So go and check your natural logs on your textbooks. You'll see that is 1. So meaning here, we have natural log E, we're going to be left with G V over CT. And then we're going to be having the same thing here as we continue here over I, J over I, J over I minus 1. Right. So what do we do here? We cross multiply. So let me just keep on creating space, guys. I'm going to keep on dropping this as well. All right. Let's keep on dropping that as well. Okay. So let's continue. So if you cross multiply, this is going to multiply that side. So we're going to left with GV, and then CT multiplied by natural log, then we have J over I minus 1. All right, so because we are making G7 formula, this is going to be G is equal to CT natural log. All right, guys, so we multiply it by CT, so we're gonna have natural log then J over I, let's not forget this is J, minus 1. Right, then we divide by V. If we divide by V, we're gonna be left with only G here, and then what you do on the left hand side, you must do on the right hand side. So this is gonna be V. So this is your final answer to get your what is this, your to get you to make G-cell formula. I hope guys this was not too much. This is basically how many marks? 3 marks. Okay, I know it looks like it's too much, but it looks like this because I'm explaining everything here. Guys, if you didn't understand this question, or if there's somewhere that you miss out, you can just rewind and rewatch the video, that part that you didn't understand. Okay guys, we are done with 3.2. It's time for us to do the other question. Alright guys, let's do question 3.3. Now I'll highlight it. This is 3.3. Now here they want you to solve the unknown if you are given this expression here. So guys, here you need to apply some sort of you need to introduce some logs or natural logs, right? So let me just write it there. So the problem that we have, which is 3.3, okay, let's rewrite it. So this is gonna be 5 2x plus 2. This is the exponent, by the way. This is equaling to 4, then exponent x minus 1. Look guys, it was going to be easier if the base are the same. We're not going to introduce any logs or natural logs, but since the base are not the same, it's time for us to introduce the natural log. So let's introduce the natural log on both sides. So if we do introduce natural log here, and then we have 5 to the power of 2x plus 1 plus 2 is equaling to, which do on the left hand side, you must do on the right hand side. Again, natural logs, this side you must introduce it, x minus 1 exponent. Right, so this is what you should do. But then from here, the next thing that you must do now is to apply the law where we take the exponent to the front. Okay, so let's do it. I did explain it when we were solving the 3.2, so I'm not gonna explain it again. Okay, so let's do it. So this is gonna be 2x plus 2 multiplied by natural log 5, right? And then this is gonna be x minus 1. Remember, we're gonna take this one as well to the front, guys. Name minus 1, then natural log 4. All right, so guys, as you can see, now it's easy for us to solve it. Remember, natural log 5 and natural log 4, these are just numbers, guys. Okay, these are just numbers, so you can treat them as numbers. So what we should do is divide by one of the natural logs here. Oh, by the way, you can use the standard logs that you are used to here as well. You're gonna get the very same answer as the one that I'm gonna get here. But anyway, let's just divide by natural log 4. Can we divide by natural log 4? If we divide by natural log 4 both sides, and divide by natural log 4 this side as well, this one here we're gonna have 2x plus 2, 5 divided by natural log 5 divided by natural log 4. What are we going to get there? We're gonna get the following: 1,6. Is it 1,16? It's 1,161 equaling to natural log 4 divided by natural log 4. This is gonna be 1, guys. So we're gonna be left with x minus 1, right? So from here we multiply, we try to remove this bracket, we multiply everything inside the bracket with 1,161. So let's do it. So if we do that, we're gonna have 2, 3 to 2x plus this one here is gonna be 2, 3 to 2 equaling to x minus 1. So if we take x to the other side, we transpose it, this is going to be 2, 3, 2, 2 minus x. And then this time around, we take this 2, 3 to 2 to the other side. Remember, we do have negative 1 here. We left with negative 1, and this is going to be negative as well. It's going to be negative 2 comma 2 3 3. All right, let's continue. So, oh, I forgot x here. Just do this. I almost forgot the x, guys. It's very simple to forget the x, guys. Okay, just write it here. It's gonna be 2 comma 3 2 2 then x. Right, now we're fine. So this 2 comma 3 2 2 x minus x, what is it that you're going to get here? We're gonna get positive 1 comma 3 2 2 then x. And then here, these ones, if you put them on the calculator, negative 1 minus 2 comma 2. Oh, I swapped again here, guys. I swapped here again. This is 3 2 2x. Okay. Yeah, as you can see, it's simple to make mistakes here, guys. Okay, especially when we're dealing with decimal numbers. We have negative 1 minus 2 comma 3 2 2x. So the answer is going to be negative 3 comma 3 2 2, and then we divide by 1 comma 3 2 2 both sides. Let's just do it. 1 comma 3 2 2, and also we do the same thing here. 1 comma 3 2 2. Right, let's create more space, guys. More space. So this is gonna give us x, and that is gonna give us negative 2 comma 5 1 3. So this is your answer for 3.3. I hope you guys managed to understand this question, because it can be challenging. The thing that you were supposed to do here, it was to actually change or introduce natural log. Let's just go back there. It was to introduce natural logs here. Okay, I hope you guys understood this question, and I hope you can able to do it next time when you do this one. All right, guys, we are done with question 3.3. Now let's go and do the next question. All right, guys, now let's do 3.4. Now let me highlight it here. 3.4 is this one here that you see. Now what is it that they want here? They give you the impedance of the circuit is given by this equation here. ZT is equaling to Z2 over Z3 plus Z1. So they say to calculate Z total if Z1 is equaling to 2 plus J3, Z2 is equaling to 3 plus J4, and then Z3 is equaling to 5 minus J4. And then they want you to leave in the answer in a polar form. So this is very important, guys. All of this is very, very important. Now let me just go back so that you can able to see this question. Let me just highlight the things that are important. First of all, they want you to leave the answer in polar form. Okay, and then 2, they give you your Z1, able to see Z1, Z2, and Z3, and 4, you have the equation there that you must use. So how do you gonna do this problem here? All right, let's start. So first of all, let's rewrite this question, which is gonna be 3.4. So 3.4, we are given Z total. So Z total. Oh, by the way, this is given to us with this is a rectangular form, guys. Just in case you didn't know, this is a rectangular form. So it's given in a rectangular form. We know that Z2 over Z3 plus Z1. Okay, now let's rewrite this Z total. So wherever there is Z2, we just substitute with this one here, guys, z2. So z2 is on the numerator, which is going to be 3 plus j4. Remember, j is another way of representing the imaginary number. Okay, and then what about the denominator? We have z3 plus z1. So z3, if you look here, it's just put it in the bracket. Z3 is 5 minus j4 plus, right, plus z1. So z1, you put it in the bracket as well, it's going to be 2 plus j3. Okay, so this is how you do this one, guys. This is how you do this one. I hope you can able to see. Now, first of all, the numerator there's nothing we can do. We just leave it like that. And then on the denominator, let's remove the brackets. Can we remove the brackets on the denominator? Because this is plus, so the brackets we can just remove them. So we're gonna have 5 minus j4 plus multiplied by 1 here, so it's gonna be 2 plus j3. There we go. Now let's continue. Z total, close here. Z total, guys. I know some of you are doing mechanical. Don't be intimidated by the jargon that they use here. This is electrical stuff, by the way. But if you remember the complex numbers, this is gonna use what we know with complex numbers when it comes to math. So I know this can be intimidating, especially when you read the question there. Right? Divided by. Now let's look at our denominator here. We have a real number, which is 5, and we also have a real number, which is 2. So they are both positive. They're going to give you 7. So when you add them, and then we have imaginary number, which is 4 here, negative 4, and we have a real imaginary number, which is going to be positive 3. So negative 4 minus plus 3 is going to give you minus j. Okay, now from here I want you to pay attention, because that's where I lose lots and lot of people here. Here you have to multiply by the conjugate. Remember, guys, the conjugate of for example, let's say the conjugate of 1 minus maybe 2j, or the conjugate of this is gonna be, remember this is z, the conjugate of this, which is z, is bar z, it's 1 plus. So we change the sign of the imaginary number, guys. Okay, for the conjugate we only change the sign of the imaginary number. So we're gonna multiply by the conjugate, but those conjugates must give us 1. So meaning we must change this and say 7 plus j. Remember, this is the conjugate of the denominator. Divide by 7 plus j. 7 plus j over 7 plus j, this is 1. All we are doing here is to multiply with the conjugate. This is similar to rationalizing. Right, so let's look at the numerator. When you look at the numerator, let's do the multiplication. You say 3 multiplied by 7 is going to give us 21. All right, and then you say 3 multiplied by j is going to give us plus j3. Okay, and then we come to this one. j4 multiplied by 7 is going to give us plus 28. Let me double check. Yes, it's going to be 28. Right, and then j4 multiplied by j, this is gonna be plus j squared 4. Then we divide there, guys. Let's just divide. Okay, guys, this is a difference of 2 squares, so I'm not gonna do the multiplication here, but you can do the FOIL. You can multiply throughout, but I know that this is gonna be 49, because it's a difference of 2 squares, guys. The first one is negative, the second one is positive, so it's a difference of 2 squared minus j squared. but you can do the multiplication. You can do the multiplication if you feel like something is missing here. So let me create more space for us guys so that we can able to continue and solve this problem here. All right, so what you need to know guys is the fact that we have j squared. What does j squared mean, or how can we deal with j squared? So let me just remind you very quickly guys about j squared. J squared guys, it's j squared. If you still remember from our lessons, or from your, you can go to your book there guys and check. If you remember though from our lessons, or you can go to your book again, we know that j squared is equal to, here, j squared is equal to -1, or I squared. Imaginary, remember j stands for imaginary, so it's gonna be -1 when it's squared like that. So wherever there is a j squared, we can substitute with -1. So let's continue here. So total impedance, or yes, total impedance. So this is gonna be 21. We are fine with 21, and we have the like terms here. We have 3j plus 28j. That's gonna give us 31j. Okay, and then here we have j squared. So you can do this. You can say minus, because meaning we're gonna have -1 multiplied by 4. So this is gonna be minus 4. Then we divide them, and this is gonna be 49 minus, and then what do we have here? -1. Okay, remember this is j squared, minus 1. So that is j squared. So we can continue. Now let's look at our, let's continue guys. Let's look at our numerator there. Let's look at our numerator. Our numerator, we have 21 and -4. Those are like terms. Okay, I hope you can be able to see. So what is 21 minus 4? 21 minus 4, if I'm not mistaken, is supposed to give us 17, right? And then here we're going to be left with plus 31j. Okay, divided by, now what do we have here? If we have 49 minus minus, this is going to be positive 1, so 1 plus 49, this is going to give us 50. Right, so from here we can continue and divide. All right, this question might take longer because there's a lot happening here, so bear with me guys, bear with me as we solve this one. So we can say total impedance, we have 17 over 50. Remember they are divided by one denominator. We can separate it this way here, and then we have 31 j divided by 50. It's the same denominator. So what I did here is the same as what we have here guys, right? So total impedance, we want to get rid of the fractions. So if we do that, this is going to give us 34, oh, 0 comma, not 34 guys, 0 comma 34, 0 comma 34 plus. So what are we going to get for the other one? It's going to be 0 comma 62 j. Okay, you can say j 0 comma 0 comma 62 guys. Okay, so this is the final answer when it is rectangle. But remember guys, they want you to change this to polar form. See this highlight, change this, give the answer into a polar form. Now in order for us to get the answer in a polar form, we need to calculate the modular. Remember the modular? So the modular is we're gonna use the theorem of Pythagoras. So it's more like the radius guys, the modular. okay, is a real number, by the way. So the modular is going to be like this. Now, theorem of Pythagoras. Now, I need to remind you guys that this one here, let me just use a different color. The real number represents x, and then the imaginary number represents y, right? Okay, you don't have to draw the diagram here. They never said anything about drawing the diagram, so we are fine. So we know that it's going to be 0,34 squared plus 0,62 then squared. Let me just erase this. Alright guys, we need to erase this. It doesn't look good. So let me just erase what is inside here and write what looks good. Okay, remember this is 0,62. Now it looks professional. No, it doesn't look professional. 0,62. Yeah, there we go. Now we are fine. So this is the modulus. So when you put this on your calculator, your modulus is going to be 0,707. Right. Now it's time for us to get the angle. Remember, the polar form notation is like this. It's going to be z total. Just in case you forgot, real number, then the angle here, guys. Okay. So this is the modulus and this is the angle. All right. Let's get the angle. Let me just create more space here. More space, guys. We need more space. Okay, let's continue. So the angle, we're gonna use tan theta, which is gonna be equal to, now what is tan? Usually tan is y over x. So where do you know which one is y, which one is x? Remember, the real number, guys, the real number is x and the imaginary number is y. So just substitute them here, which is going to be 0,62 divided by 0,34. So when you say arctan, remember you have to say arctan to get an angle. Arctan 0,62 over 0,34. 0,34. So the angle that you're going to get here is going to be 61,26 degrees. Guys, there's no need for you to multiply, to minus or add with 180, because we know that if both the imaginary number and the real number are positive, it means they're both happening on the first quadrant. Remember, this is a real number. Real is positive here, and then imaginary, it's also positive. So it's happening on the first quadrant, and the angle on the first quadrant is less than 90. So there's no need for you to minus or add with 180. Okay, so let's try to write it in a way that we can able to represent the point. All right, guys, let's write it. So total impedance in the polar form, we do have our modulus, which is 0,707. That is a real number, and our angle is going to be 61.26 degrees. So this is your final answer, guys. This is your final answer. I hope you managed to understand what we did here. Again, if it so happened that you didn't understand what we did here, you can rewatch the part of this video until you see what is it that you missed there. I hope you do have the basics though, but I hope I managed to explain those basics. So now we're gonna be doing the next question. So let's pause here and then we'll do it after. Alright guys, now it's time for us to do the 3.5. Now let's highlight this question here, which is 3.5. So 3.5, as you can see here, they just said solve for t if you are given this expression here. Now remember, we are still under
um, imaginary or complex numbers. So guys, this at some point it will give us an answer with complex numbers. But let's see guys, let's see. Now 3.5, let me write it here. 3.5. So they want you to find t. So we have t squared minus 2t plus 4. This is equal to 0. So how are we gonna do this one? All right, so let's do it using the quadratic formula. Remember guys, we cannot vectorize this. What are the factors of, because we have minus plus here, meaning the factors they must add. The factors of 4, when you add them, they give it to, we don't have them guys. We cannot, we do have them, but we cannot get them in a simple direct factorization. We need to use the quadratic formula. So let's use the quadratic formula here. So quadratic formula, we know that we have negative b plus or minus, then we have b squared minus 4ac, right? This is divided by 2a. All right, so it's time for us to substitute, but before we substitute, let's just write our quotient, the coefficients there. We have a, which is 1, the coefficient of t squared. We have b, which is negative 2, the coefficient of t to the power of 1. Let me just write it here. And then we have c, which is our constant. All right, now it's time for us guys to do substitute here. So let's substitute. So wherever there is b, we have to put the negative 2 there. So it's going to be negative 2 plus or minus. Now we're going to have b squared here, negative 2, then squared, minus 4, and then a. What is a? A is 1, and then c is going to be, what did I put 0 there guys? C is supposed to be 4. I made a mistake, I put 0 there. I hope you managed to see that one, right? It's going to be 4. Positive 4 guys, right? C is positive 4. And then we divide by 2. We divide by 2 multiplied by a, which is 1. Right, so when we continue and do this one here, we're going to have positive 2, negative, and negative. We're going to give it positive, and then let's say plus. Remember we have plus or minus. Let's start with plus. So if we have plus here, this inside the bracket, inside the root, if you put this inside the root here, your answer is going to be negative 12, right? Don't try to put this, the whole of this on your calculator. You're gonna get an error. Your calculator, remember we have a negative under the square root, it's gonna give us an error. So rather do it the way I'm showing you here guys. Okay, divided by 2. All right, and the other one here, now we have x, and then is equaling to 2. This time around we have negative, and then we have negative 12 over 2. Remember, this one is when it's positive there, and this one here on the side is when it's negative here. So there's a certain information that I need to add with you guys. Remember, the imaginary number is actually a negative square root, negative 1 under the square root. Let me just write it right. Imaginary number, the I or j is equal to negative 1 under the square root guys. Okay, so how can we change this? How can we change this to have that notation? So here's what you can do. You can say x, then we have 2 here plus, and then we can say root, where are we? Just pause here. All right guys, let's try to write it in a way that we're gonna be able to include this negative 1 under the square root. But we know that we can. Let's try to do the 12. We know that 4 multiplied by 3 is gonna give us 12. And then this we can take it aside, which is multiplied by negative 1. Remember, if you multiply numbers which are under the same root, it's the same as uh, when you multiply them under that root, guys. Okay, if the root is the same, if it's the square root here, the square root there is the same as they are multiplying each other. The reason why I took it there on the side is because we know that this is gonna be I or J. Okay, let's continue. This is gonna be that. Now we have that is gonna be 2. We do the very same thing that we did on the other side, where we have we're gonna have 4 multiplied by 3, and then multiplied by, just create more space here, guys. Create more space. Multiplied by root negative 1. Okay, this is divided by 2. Okay, now it's time for us to continue. Let me see if we can able to see this. Yes, let's create the space here. Let's keep on creating more space, guys. We need to create more space. We need to create more space. All right, now how are you gonna do this one? Now let's start with the first one here. We have 2 here. Now what is the square root of 4? Plus the square root of 4 is gonna be 2, but inside the root, what are we left with? We're gonna be left with 3. Now, by the way, what is square root negative 1? This is gonna be I O J. Okay, there we go. Plus or divided by 2, right? And let's go to the other one here. Okay, it was a bit tricky, guys. I hope you managed to see this. And then same thing here. What is the square root of 4? It's gonna be 2, and inside the bracket you're gonna left with 3, and then multiply by what is negative 1 on the square root. This is gonna be I over 2. Okay, now if you continue here, you just create more space here. Okay, all right, now here we can say x is equaling to 2 over 2. Now we can remember they have the same denominator, guys. We can separate them. 3j over 2, and do the same thing this side. We have 2 divided by 2. The denominator is the same, guys. It's 2, so we don't have to worry about that one. Divide by 2 and j or I. So we know that 2 into 2, we're gonna be left with 1 here, and then here what are we gonna have? 2 into 2 is 1, 2 into 2 is 1, plus, let me just put I here, root 3, and then the other one here, which is gonna be 1 divided by 1, 2 divided by 2 is 1, and then 2 divided by 2 is also 1, multiplied by j or I, and then the root 3. Guys, I hope you managed to see this one. It was a bit tricky at the end here. It was gonna be simple for you to make mistake here, but I'm glad that we managed not to make any mistakes, because it's very simple, guys. So these are the answers for both t. I don't know why I use x, guys. They are looking for t, so please do not forget to just write t here. Let me just erase, guys. They're not looking for x. You see the all have it. It's actually t. Let me just erase it here, guys. It's actually t that they are looking for. Unfortunately, it's gonna take our time, but from here, guys, I hope you can see though what we are trying to do. This is t throughout, guys. T throughout here. T, they're not looking for x, guys, plus t that they're looking for. Okay, right, so this is basically that. So t is gonna be 1 plus imaginary number root 3 t minus imaginary number root 3. I hope this was useful to you guys. If you so happen to understand, you can start this section of this video and then watch this question again. I hope you were able to understand. All right, now we are done with this question, which is 3.5. The last question that we have to do is the one of the conjugate. It's only 1 mark, guys. Let me just do it very quickly. And then we are done with this question 3. So this one here, guys, it's a conjugate, which is 3.6. Do you guys see 3.6 here? They want you to state the conjugate of J3. Guys, remember I did explain the conjugate here. I don't think you really have to worry about this one. I'm just gonna be quick about it. Remember the conjugate, it's gonna be negative J then 3. So you can write it like this if you want to, negative J3. If it's positive, the conjugate is going to be negative. If it's negative, the conjugate is going to be positive. That's it. Guys, this is the end of question 3. I hope you understood how we solve majority of these questions. If it so happened that you didn't understand, you can leave a comment on the comment section. And also, do not forget to subscribe if you haven't subscribed.
Let's do question 4. Already I highlighted question 4 there. Okay, now let's look at this question. Let me just take it this. Yeah, let's look at this question here. So question 4.1, they what is it that they want here? So let's read the information here. First erase this so that you can able to read it all together. All right, so what is it that they want? Highlight there. Let's read there. 4.1, in the application of Kirchhoff's law in a circuit, the following equations are obtained. So this is just the statement. So we have this equation here, equation number 1, equation 2, and equation 3. Now what is it that they want us to calculate here? They say determine the value of I3 by only using Cramer's rule. So this chapter here, guys, is determinants. I hope you were in class when we're doing determinants. If you're not, then let's hope this is gonna help you understand much better. So this, it was about 8 marks. All right, so as you can see, we have this equation here, and then if you can see the first equation, I2 is on the other side, so we need to transpose it to the other side. And we also have I3 also, which is on the what is this, the right hand side. We need to take it to the left hand side. And also I1 here on the last one, it's on the right hand side. We need to take it to the left hand side. So before we start, we need to rewrite this. So let's start. So we have we have 3. Let's start with this equation here. We have 3, and just write on top here, this is 4.1. So we have 3 I1, right, plus, wait, we cannot say plus, we need to say minus, because if we take this I2, 5I2 to the other side, it's going to be minus 5I2 plus 3. Remember, guys, they must be in an order. Plus 3I3, and then we leave the constant here. We leave the constant here, which is 7, 5, which is 7, 5. There we go. All right, so let's continue. Let's do the second one. Let's rewrite the second equation. So the second equation is gonna be 2 I1, and then plus I2. As you can see, this one is still fine. Now we're going to take this 7 I3 to this side, so it's going to be negative 7 I3, and we are left with what on our left hand side. On our right hand side, we're going to be left with 17, 5. There we go. So the last but not least, as you can see, I1 it's on the right hand side, you need to take it to the left hand side. So if we transpose it, we're going to have negative 10 I1 plus 4 I2 plus 5 I3. The answer is going to be 16. So our constant here is 16. So guys, when you're able to write it like this, it's time for us to write it in a matrix order. Okay, so remember, we only take the coefficient of the i's here. So for example, let's start with the first equation. So the coefficient of I1 for the first equation is going to be 3. And then the coefficient of I2 is going to be negative 5. And the coefficient for I3 is going to be positive 3. I hope you guys can see that. And now let's go to the equation number 2. The coefficient for I1 is going to be 2. The coefficient for I2 for the second equation is going to be 1. The coefficient of I3 is going to be negative 7 for equation number 2. The last equation, the coefficient here is going to be 10. Negative 10, by the way. The coefficient for I2 is going to be 4. And then the coefficient for I3 here is going to be 5. So we are fine. We leave it like this. Okay, so this is fine. So when it's like this now, we can able to work with this. So what is it that they want from us here? They want us to determine the value of the I3 by only using the Cramer's rule. So the Cramer's rule here, we need to first find the determinant. So before we find the determinant though, we have what you call the cofactor. I'm gonna write the cofactor here. Let's write it here. Or let me just write it on the question paper. Let me write it on the question paper. So the cofactor, I hope you're able to see. The cofactor is the signs within the matrices, the matrix. So we have the first one is positive, and then the alternate is negative, then the other one is positive. And then on the second, it's the first one is negative and that one is positive, and this one is negative. And then that is going to be positive, negative, and positive. These are the cofactors. Always like that, guys. If you can able to know the first one, just know that they alternate. The first one is positive, then negative, positive, negative, positive, negative, positive, negative, positive. That's it. They just alternate. All right. So, but before we start, before we continue, you need to know that we have a column. So this side here, I'm gonna highlight with not highlight yet. We have a column. So column is when you have it's, for example, the first column here is going to be 3 to 10, and then we have a row. A row is going this direction in a vertical direction, or in a vertical direction, which is 3, negative 5, and 3. Column on a horizontal. Oh, I mixed them, guys. A column is on the vertical direction, like up or down, and then a row it's on a horizontal direction, left and right. Okay, so I hope you can able to see that. So before you find the determinant, guys, you just need to choose at least one column or one row. So I would advise you guys to use a column, the first column or the first row. This one is up to you guys. Let me just highlight it. So let's use the first column. Can we use the first column? let's use the first column. I'm gonna highlight it like this so that we know that we're gonna use this first column to use the numbers as minus. Okay, so we use the first column. So these numbers that are going to appear, 3, 2 and -1, they're going to be in minus. They're going to help us to find the determinant. So let's do it. So guys, before we start, the formula for determinant, usually it's let's say we have 1, and let's say we have a, and then we have a1. Let's say we have a2, a2, and then you have we have b1, for example, and then you have b2. Just an example, guys. The formula for finding the determinant, you multiply a1 with b2, so it's a1 multiplied by b2, then minus, always minus a2 multiplied by b1, so a2 multiplied by b1. So this is the formula to find the determinant, just in case you forgot. So here we need to use a minor to find our determinant. So we start here with 3. So with 3 here. So when you start with 3, we need to cancel the side, meaning if we take 3 as a minor, we have to cancel it here, guys. Okay, these two parts here we cancel, so you're gonna be left with 7, with 1, -7, 4 and 5. So let me try to find some but yeah, that's what you're gonna be left with. So let's do it. So when the minor, let me just scroll this down. We're gonna need more space, guys. We're gonna need more space. Okay, yeah, for now this is what you're gonna need. So when the minor is 3, start by finding the determinant. We're gonna need the space here. So when the minor is 3, the row that is within that 3, the column that is within that 3 is cancelled, and the row is also cancelled. We left with 1, -7, 4 and 5. So we can write it like this for you to understand. Guys, we write the minor, but if you look at the cofactor is positive here, so this is going to be +3. Then you write then 1, -7, 4 and then 5. I hope you guys understand, because I feel like I'm all over the place though. Right, then you go to the next minor, which is going to be 2. So if our minor here is 2, this is going to be cancelling this way and that way. So you're going to left with -5, 3, 4 and 5. So don't forget, if the minor is 2, we're going to be cancelling this way and that way. Okay, -5, 3, 4 and 5. But now let's look at our cofactor here. So our cofactor is going to be negative. Since we have 2 here, so our cofactor is going to be negative. All right, so this is going to be negative, right? So remember, our what is it that we're going to be left with here? It's going to be -5, -5, and then 3, and then 4 and 5. Okay, this is a long way of doing it, but I think it's necessary for us so that we can able to find the right answer. Okay, now let's do the other one, the last one. Now this time around the minor is gonna be -10. So 10, and when we cancel the row and the column of this 10, the column and the row, we left with -5, 3, 1 and 7. Since 10 is positive and the minor there, since 10 is negative and the minor there is positive, so we can write it as negative 10. Okay guys, I hope this one affect the audio. The thing is starting to be slow now, the computer. Okay, so we're gonna left with what? -5, and then we have 3, And then what else do we have? 1 and -7. Okay, let's double check, guys, if this is correct. Remember, we are cancelling this row here and that column. We left with -5, 3, 1, -7. All right, so we are fine. Okay, guys, I hope we can able to do this one here. So let's do it. So here's what we're supposed to do it. We have D, then we have 3. So here's how you're supposed to do it. Say 1 multiplied by 5. So 1 multiplied by 5 is what you get there, minus, always minus, guys. Okay, -7 multiplied by 4, -7 multiplied by 4. All right, so this is gonna be our, it's gonna be this one here. Let me just erase this 4, doesn't look so good. -7 multiplied by 4. Okay, yes, this is what we have here. All right, so we go to the second one here, -2. With -2 now, we're gonna have -5 multiplied by -5. You put this on the bracket, -5 multiplied by -5, and then we say minus. Always, guys, you multiply this and then you multiply this, and then it's gonna be 3 multiplied by 4. 3 multiplied by 4. There we go, and then close the bracket. Now the last one, I hope you're gonna have enough space here, but if you don't, let me just create a little bit of space here. And -10. Remember, the minor is gonna be outside, guys. Okay, so this time it's gonna be -5, -5 multiplied by -7, then minus. Okay, minus 3 multiplied by 1. So this is gonna be 1 multiplied by 3. So this is what we're going to have. I hope you guys can see, though. Remember, it's the first multiplied by the last, and then minus by the product of the second multiplied by the third. And then we come here, the first multiplied by the last, the second multiplied by the third, and then and so on and so on. So if you continue here, this is going to give us 3. Inside the bracket there, we'll be having 33. There we go. But you can use your calculator, guys. You can pause and use the calculator and see if we have the same thing. And then here we're gonna be having 2, and then we use 37. Okay, and then here we're gonna have -10, and then inside there we're gonna have 32. So when you multiply this, they must give you, when you put everything in a calculator here, this should give you -147. Guys, please be careful when you use a calculator here, guys. Be very, very careful. It's very very possible for you to make a mistake here. Okay, now we managed to find the determinant. Okay, now in order for us to continue to find the determinant for, let me just open the space here. In order for us to find the determinant for I3, remember, we need to find the determinant for I3. So what's going to happen, guys? Let's go back on top here. Just go back. I want to explain something. In order for us to find the determinant for I3, I want to show you something. You see these constants here, you have to move them where the values or the coefficient of I3 are. Basically what I mean is, instead of writing 3, you must write 7.5. Instead of writing -7, you must put in 17.5, and then instead of 5, you're going to write 16. The reason why we put them here is because we are looking for the determinant for I3. So let's rewrite this where we just change only the where we substitute only the constant. I hope you guys managed to understand that one. So I have to redo this matrices. I hope this is gonna be enough. So I have to zoom it out, guys. I have to zoom it out. So let's do it here. Let's do it here. All right, close this, and then let's rewrite. So Okay guys, so let's redo it. So let me try to do it like this. There we go. And then we know that this is going to be 3, this is going to be 2, and that is going to be negative 10. This is going to be negative 5, that is going to be 1. Let me just, space is too much. It's going to be negative 5, that is going to be 1, and that is going to be 4. And then this one here, remember we substitute with the constant here. So we have to, okay, it's fine, I can able to see them here. We have 7, 5, and then here we have 17, 5, and the last one here we have 16. There we go. And then we can leave it like that. Okay, let me just go back a bit, and we can just, yeah, it's fine like that. All right, it's time for us to drag this downwards. Okay, we just leave it here. Remember, this is question 4, so this, I don't know what's happening here. Okay, let me just erase this. It's still fine, it's still fine. So let's zoom in. Zoom in, guys. Okay, something I need to. Okay, it's fine. Let's leave it like that. Okay, let's leave it like that. What's happening, guys? What's happening? What's happening? Okay, yes. So let's continue, guys. Sorry for wasting the time. Excuse me there, guys, but we have to do it this way. Okay, let's look at our question 4. Let's look at our question 4. Now, remember, now we are trying to find the determinant of I3. So the determinant of I3, again, guys, I would say choose the first row, by the way. Okay, choose the first. Let me just highlight again. Choose the first column only. You can choose any column, any row, by the way, in order for you to use this as your minus. Okay, you can choose any of these two, any column, by the way, guys. But it's easier when you choose the first row or the first column. So I decided to choose the first column. Okay, let's continue, guys. So the determinant of I3. Now let's start. If we have if we take 3 as a minor, remember we have to take 3 as a minor. So if you take 3 as a minor, you see what you're gonna be left with here. You're gonna be left with 1, 17,5, 4, and 16, and the cofactor here is gonna be positive. So when we write this, it's gonna be 3, and then let's look at what we left with here. We're gonna left with 1, okay, and then we have 17 and a half, okay, and then we have 4, and we have 16. Then there we go. Right, now let's go to the second one. Now when you go to the second one, which is going to be 2, let's see if we scratch there. The row of 2 is going to be cancelled, and also the column of 2 is going to be cancelled. So you're going to be left with negative 5, 7, 7,5, 4, and 16. But since the cofactor is going to be negative here, so it's going to be negative, and then our minor is 2. So let's write what we are left with here. Remember, we are left with negative 5. There we go. And then 7,5. I hope you guys can see. And then 4, and then 16 here. Guys, I hope you're paying attention here, because this one can be challenging. Right, now if we use 10, negative 10 is our minor. Remember the highlighted one, those are the minus. So let's just okay, I don't know why the red pen, it's going to be permanent then. It's going to be this row and that column. So we left with negative 5, 7,5, 1, and 17,5. All right, so let's look at the cofactor. Our cofactor is positive, but our minor is negative. So this is going to give us a positive a negative answer. So it's going to be negative, then 10, then let's do it. So if this is our minor, we have negative 5, right? And then we have 7,5, okay? And then here we have 1, and then we have 17,5. Right, this doesn't look like 17, but guys, it is 17, okay? It is 17. And then that's what you're left with. So remember guys, we need to do the multiplication, so let's do it. ID3. Okay, I know this is gonna take a little bit of time, but guys, remember the aim is to understand. Okay, so how do we do it? We say 1 multiplied by 16. Remember, it's the first and the last first, so it's 1 multiplied by 16. There we go, minus, now this product here, minus by the 17 multiplied by 17,5 multiplied by 4. I think we're gonna need more space here, and then we have minus here. Okay, now negative 5 multiplied by 16 is gonna be, put it in the bracket since it is negative 5 multiplied by 16, right, minus, and then we have 7,5 multiplied by 4, 7,5 multiplied by 4. There we go. I need to open more space, guys, unfortunately. All right, so the last one, which is gonna be 10. There we go, 10. The minor is 10, and then what about what is inside 10? We have negative 5 multiplied by 17. Negative 5 multiplied by 17,5. There we go. And then minus, let's open a bit again. Okay, we have that. Let me just get rid of this, guys. This is kind of requires some space. Okay, so we said negative 5 multiplied by 17,5 multiplied by 7,5 multiplied by 1, so minus 7,5 multiplied by 1. There we go. Now this is our equation. Now it's time for us to start multiplying. So let's multiply, and let's see what is it that we're gonna be able to come with. Okay, so let's do it, guys. Let's do it. Okay, so let's do it. Di3, the first one is going to be 3, so inside the bracket there we're going to be having 54. There we go. And then we have negative 2, the minor. Then inside the bracket here we're going to have negative 110. Okay, and then the other one is negative 10. As much as they are long, when it comes to this part, they're no longer that long anymore. We're going to have negative 95. All right, so now that we managed to get this, it's time for us to find the final answer. So the final answer for the determinant of I3, if you put this on a calculator, you will have 1008. So that is your determinant for what is this, I3. Okay, now how do we calculate the unknown? Remember, the question is calculate. Let me just go back. Remember, the question says calculate the value of I3. Now when you calculate the value of whatever that is required for, in this case it's I3, the formula is like this: I3 is equaling to the determinant of I3 divided by the determinant that we calculated earlier on. Okay, so if you still remember, the determinant of I3 is this one here, which is 1008, divided by the determinant that we calculated earlier on. Let me just go up so that you can see it. This one here, and then when you divide there, this determinant is going to be, don't forget that determinant, it's also negative. So it's negative 147. and then our final answer is gonna be 48, negative 48 over 7. Or if you decide to write it in a decimal point, it's gonna be negative 6 comma 857 857. So this is your I3, guys. I hope you manage to get this one, guys, because it has a lot of things to do, but it makes sense because it's um, 8 marks. So I hope you manage to see to get this one, guys. As you can see, we have a lot of determinants to get to have a lot of metrics to do, a lot of things to do here, guys. Anyway, and don't forget that you need to know the cofactor, right? The cofactors are very, very important. Okay, guys, let's just pause on this one, and then we'll do question 4.2. All right, guys, now let's do 4.2. Now 4.2, it has 4.21, 4.22, so we must able to do these ones here. So what is it that they want us to do here? Let me just highlight. Remember, let's just highlight. So 4.21, they want you to determine the cofactor of -1. Now when you look at our matrix here, -1 is this here. Do you guys see? Meaning now we're gonna treat this -1 as a minor. Now let's write our cofactor here, because it's very important for us to able to write our cofactor. Remember, we have positive, negative, positive, and then we have negative, positive, and then positive, negative, and then negative, positive. This is our cofactor, guys. Just like the first question, cofactor. Just like the first question 4.1, we use the cofactor. Guys, you must know this cofactor in order for you to able to solve these problems. So let's do it, guys. Let's do it. So what's happening here? We're gonna use this -1 as a minor, but this time around, remember, guys, we don't multiply it there, just like we did with the determinant. Here's what I'm talking about. So the cofactor, let's say 4.2.1. So the cofactor of -1, you can write here. Even if you don't write, we know that this is what you are looking for. You have to do this. -1 is equaling to. Now it's time for you to cancel the rows. So if we use -1 as a minor, let me just do this. If you use -1 as a minor, remember this row here and that column, they're gonna be cancelled out. So meaning now we're gonna be left, let's do it again, this column, this row, and that column. We're gonna be left with 1, 5, -2, and 7. So let's go and do it. So but before we do that, let's look at the minor, the cofactor. Now the cofactor, this is the third when you are with this, the second when you are looking on the last row. So the last row, the second, the sign here is gonna be negative. That has nothing to do with this negative here. So you're just gonna write it here. This -1 is this side. So you write you do your matrix there. So remember, when the minor is -1, this row cancels and that column cancels. Left with 1, right? And then 5. Don't forget this column cancels. So is this column there that is left. And then let's look at another one, which is gonna be -2 and 7 and 7. There we go. I hope you guys can be able to see this. It doesn't look so good, but let's do the 7. Just write it nicely, guys. -2, okay, and 7. There we go. So this is our matrix here. So negative 1 is equal to, now let's find our determinant. Negative there. So we say 1 multiplied by 7. This is going to be 1 multiplied by 7. This one is so simple, guys. Minus, and then 5 multiplied by negative 2. 5 multiplied by negative 2, and then the answer here, the negative minus, the answer is gonna give us negative 17. If you put that on your calculator, this is gonna be negative 17. So this is how you get the minor or the cofactor of negative 1. So that's the answer, guys, negative 17. Hence this is how many marks? This is 2 marks. You see, 2 multiplied by 2, there are 2 marks. That's why it's so short. Now what about 4.2.2? 4.2.2, remember guys, is this one here, is this one there. Now they gave us the minor. Let's read that. They say determine the minor of 0, the minor of 5 there. All right, so we need to find the minor of 5. All right, so let's highlight 5. So 5 is here, as you can see. Now how are you gonna do this? We do it exactly just like the first one here. Now we just need to highlight. If the minor is 5, what is it that we're going to be left with? We're gonna be left with negative 2, 3, 6, and negative 1. So let's do it. Let's do it. Okay, this time around, even if you don't write it like this, because they want you to find, determine the I think it's a cofactor, guys. Just do as you've done there. So it's going to be 5, right? And then let's look at the cofactor signs here. So where is 5? 5 is on the last it's on the, in fact, on the first row, and then on the first row and the last column. So this is 5 here. So when you look at the first row and the last column, this is gonna be positive. So even if you don't write here, we are fine. Remember, this is the sign that you write in front of this matrix here. So when you cancel there, you're gonna be having negative 2, and then what else do we have here? We're gonna have 3, and you also gonna have 6 and negative 1. There we go, guys, there we go. Then we start finding our answer here. So our answer, if you say negative 2 multiplied by negative 1 minus, always guys, is like when you're calculating the determinant. 3 multiplied by 6, 3 multiplied by 6. There we go. So our answer here is gonna give us, so what is our answer? This is gonna give us negative 16. There we go. So this is our final answer. As you can see, this was not much of a challenge, guys. These were 3 marks, to be honest with you. So this is 2 marks and that is 2 marks. Do not forget, guys, that this sign here comes from the cofactor. Okay, this sign that you see here, it comes from the cofactor. Remember, the minor here was negative 1. The negative 1 has nothing to do with this sign, guys. Be very, very careful. Here we don't have a sign because the cofactor sign here is positive. Here the cofactor sign here is negative. Then you start working out your problem. All right, guys, let's pause and let us do the other question. All right, guys, now let's do question 4.3. Now what's happening on 4.3? They want us to, let's look at this. 4.3 consists of 2 questions, by the way. So we have 4.3.1, where they want us to sketch and clearly label the graph of 25 y squared plus 16 x squared minus 400. This is equaling to 0. Look at this equation here, or look at this function here. It's easy to see this graph what it is. All right, let's just write 4 3.1. Guys, whenever you have the coefficient on x and y, and then here you have a constant here, usually this is going to be your eclipse. Remember the graph that looks like an egg. Okay, sometimes it looks like this, sometimes it looks like that. It's not a circle, guys. Okay, be very, very careful. So what you should do here, the standard formula for the eclipse, it's x squared over a squared plus y squared over b squared is equaling to 1. So the aim is to make sure that this equation here is equaling to 1. So let's rewrite it here so that you can have the standard formula here. So we have 25, and then we have y squared. Let's rewrite it. Can I rewrite it and start with x? Let's say we have 16. I'm just rewriting it, guys, squared. Okay, I'm writing starting with 16 plus, since 25 is also plus, it's gonna be 25 y squared, and then this is then we can if you say equaling sign, so we can take this negative 400 this side, right? If you take this negative 400 this side, you're gonna have positive 400. Okay, now remember the aim is that this equation here must equaling to 1, not 400. So in order for us to have it equaling to 1, we divide by 400. Let's divide by 400. Let's divide by 400. There we go. We are dividing with 400. Now if we divide by 400 here, we're gonna have x squared over 25 plus, now y, we're gonna have y squared over 16, and this is gonna be equaling to 1. Right, so this is now the standard formula or standard notation for the eclipse graph. So what you should know, guys, is that this number here, 25, remember, look at our general formula here. X squared is divided by a squared. So if we to look at the general formula, a squared is going to be 25, right? And then our b squared, remember, y divided by b squared, so we have y divided by 16, so our b squared is going to be 16, right? But then we don't want b squared and a squared, we just want a and b. Let's start with this. So we have to square root both sides, guys. Okay, let's square root both sides. All right, square root both sides. I hope this is going to be visible. I didn't create enough space here. Let me just write it here. All right, square root both sides. Do you guys see? All right, even this one here, b, we're gonna square root both sides. Okay, remember when you square root, we're trying to get rid of square here. Okay, trying to get rid of square. So if we have a is gonna be, what is the square root of 25? It's gonna be 5. And then b, we're gonna be left with b here. What is square root of 16? It's gonna be 4. All right, now what you should know when you draw our graph here, I'm gonna draw it here, the eclipse, the a, it's actually the x-intercept, and then the b, it's actually the y-intercept, based on this formula here. Remember, a is divided by, remember, x is divided by a, so whatever a is the x-intercept, and then y is divided by b, whatever b is the y-intercept. So let's draw our graph. So when you draw your graph, make sure, guys, when you draw your graph, you show your intercept, okay? Because that's basically what they mark most of the time. All right, so you don't really have to write 1 2 3 4 5, you just have to write the intercept. So this is y, and that is this is y-axis, and this is x-axis. All right, so a, which is y x-axis, so you can say this is gonna be a, okay, which is 5. There we go. And then this one, let's say it's also here. Don't have to measure, guys. This is gonna be 5. Remember, time is not on our side, but this is gonna be -5. Time is not on your side, guys, so make sure that you don't waste time. Now let's look at b. Remember, is a y-intercept, so you can put it here. Just make sure the distance between 4 and 4 is less than the distance between 5 and 5, so that it can look appropriate. So we have 4 here, okay? And then this one, you can say it's also -4. Now let me use a red marker there so that you can draw a graph. So all you have to do is to connect this intercept. You see, guys, connect this intercept. Now let's try this thing. Sometimes it creates a line sometimes, so I'm gonna try to draw it in a way that it doesn't create a line. There we go, there we go, there we go, there we go. Guys, this is your graph. Even though mine doesn't look so good, but it's supposed to look like something like this. Make sure, guys, you show the intercept here, guys. Make sure you show the intercept. You don't really have to write 0, 5, 5, 0, whatever. You just have to show the intercept. Now this is the graph that they are looking for, and this, guys, is gonna give you how many marks? 3 marks. It makes sense. This is not that difficult, guys. It's a straightforward type of a question. All right, let me just inform you guys, if it so happen that you have a subtraction between y squared and x squared, it's no longer the eclipse. Usually when it's negative y squared or coefficient y squared or coefficient x squared, just know that it's now a hyperparabola. Okay, there is a graph that we call hyperparabola, but when it's plus like that, then it's a eclipse, guys. All right, guys, now let's go and do 4.3.2. This one here, let's do 4.3.2. Guys, this question here, it's 1 mark, so it's a matter of asking a question. They are asking about which axis is the graph of 25y squared plus 16x squared minus 400 equal to 0. In question 4.3.1, symmetrical, right? So the question is, in which axis is this graph here symmetrical? Remember, we have how many axes here? We have 2 axes. We have y-axis, right? And then we have, let me just show you, we have the y-axis here and we have the x-axis. Okay, so they're asking which of these 2 axes, when you cut this graph, you're gonna have half of it. So let's see, if you cut it here, even though my graph is ugly, guys, we're gonna have half of these 2. It's gonna be 5 and also 5, and 4 is gonna be 4 and 4. If you cut it on the x-axis also, you're gonna have half and half. You're gonna have 4 and 4. So when you answer this one, guys, when you answer this question, which is gonna be 4.3.2, they ask which axis is gonna be symmetrical. You can say x-axis because it's also symmetrical, x-axis or y-axis. Okay, so this, you're gonna get the answer here, because when you cut on the x-axis, we have half of this graph. When you cut on the y-axis, you're gonna have half of this graph. Remember, guys, symmetrical, it means half. Okay, basically it means half of the graph. Okay, all right, guys, I hope you managed to get this one. Now we're going to do the next question. So let me pause here so that you can able to do the next question. Right, guys, now it's time for us to do 4.4. Now 4.4, let's see what is it that they want from us here. They say sketch and clearly label the graph of y is equaling to natural log x. So guys, as you can see here, we need to draw a graph of natural log x. There is a way of doing it which is simpler. but I'm gonna show you that way, guys. I think it's gonna be easier. First of all, let me write the function here. We have y is equal to natural log. Now remember, this graph here, we know that it's supposed to asymptote somewhere. So if we substitute, for example, let's say we substitute the x with 0, this is gonna give us undefined, okay, or error. So this means asymptote, guys, okay. If you have a let's just say infinity, if you have something like this, undefined error, it just means that at 0 it doesn't cut 0, okay. The asymptotes at x exists. So we know that our graph at some point is supposed to look like this. Oh, it looks so ugly. It's supposed to look like this, okay. Never cut x, never ever cut x. It's supposed to look like this, or it's supposed to look like that. Do you understand, guys? Or on the other side, but we know that it will never ever cut x, because when you say x is 0, it gives us undefined there. In fact, it gives us error on our calculator. So we know that. So now we can use the table. Let's use the table. Now when you use the table, guys, rather use 3 values here, guys. Rather use 3 values, okay. Let's start here. Let's do it. Remember our formula, we just substitute x and then we need to get y values. So we can say 0, 5, this is x and that is y. And then we can also say 1. Make sure 1 is there, guys, okay. 1 is always there. And then we have 2. All right, we cannot use negative answer, because when you substitute with a negative answer number here, it's gonna give us the asymptote as well, the error. So start from any positive number, which is less than 1 though, and then you continue. So start with 0, 5, then 1, then 2, or 0, 5, 0, 1, but all you need is only 3 values of x. So let's start. If we substitute here with 0, 5, remember, let me just do it here anyway. If we say y is equal to natural log 0, 5, what is our y? So I'm going to write it here. So our y is going to be negative 0, 7, right? It's actually 0, 69 something, but you can round it off and make it 0, 7. But then if you substitute by 1 now, natural log, then you put 1 here, so the answer is gonna be 0. I think that's where it intersects the the y axis. And then what about when you put 2? So if you put 2, okay, this is gonna give us, okay, y is equal to natural log 2. So you're gonna have something like also positive 0, 7. Now let's start drawing the graph here. Let's draw the graph. I hope this is gonna help us. Okay, this is too close to the table. By the way, they don't give you marks for the table, okay. It's to make our life easier, okay. And then we do that. All right, that is 0, that is y, and that is x. Okay, let's look at this. When x is half, so if this is 1 and that is 2, let's make it 1 and that is 2, and let's make this one 1 and that is 2. Remember, we need to make the negative as well, -1 and -2, and this one is -1 and that is -2. All right, so let's use the red pen. If x is half, so half is somewhere here, guys, right? Half is in between here. Y is negative, and y is gonna be negative what is it, negative 0, what is it? 0, 7. So 0, 7 is gonna be somewhere here and half is gonna be there. So you can do this, okay. This is half, right? Try to section, and negative 0,7 is somewhere there. Where they intersect, they're gonna give you a dot there. And then when x is 1, what is our y? Okay, when x is y, this is our y. All right, and then when x is 2, so this is 2, what is our y? It's going to be positive. Let's take it there, and that is going to be 2. All right. Okay, guys, I think I made a mistake when I say it asymptote at x. I forgot this is y. It asymptote at y, guys. Okay, this is equaling to y. I hope you can see, guys. I hope this doesn't confuse you. But from there, all you have to do is connect the dots. Okay, so you connect your dots. Let's connect the dots, and that is that. Remember, it doesn't cut y. It only asymptotes at y. So this is our graph, guys. I hope you can able to see this. What matters most here is the intercept. So make sure that you show the values of the intercept, which is 1 and 0. You can even write them here and say 1 and 0, so that you can get your marks there. So this question, it was about 2 marks. So you get 1 mark for a graph, 1 mark for the intercept. So this was very, very simple and straightforward. So they don't mark you for the graph, guys, unfortunately. And remember, guys, I repeat, when x is 0, y is undefined. It means it's gonna asymptote at y. It doesn't cut y. I made a mistake at the beginning of this question. I said it doesn't cut x. No, it's actually it doesn't cut y. All right, guys, now let's pause, and then we will do 4.5. Okay, guys, now let's do 4.5. Now 4.5, what is it that they want here? We are given a graph that we need to sketch and label the graph. So here's the graph here. The graph is y minus 3 equaling to x squared. Now let me just write it here, 4.5. So we have y is equaling to negative 3, and then this is x squared. Now if we make y substitute the formula, you're gonna have x squared plus 3. All right, now let's find y. When x is 0, what is y? So we are actually looking for the y-intercept when x is 0. So wherever there is y, wherever there is x, we substitute with 0. 0 squared plus 3, and then meaning our y is going to be 3. So the point here, let's call this point A. This point here is going to be 0 and 3. But let's look at the x-intercept. Now if we look at the x-intercept, remember we say when y is 0, what is x? Now taking it from here, look, when y is 0, we're gonna have x squared plus 3. We're gonna take 3 to the other side. We're gonna have x squared minus 3. As you can see, we have to square root here and square root there, but this is gonna be undefined, invalid. So basically this means that we don't have the x-intercept. Now how about we look for the turning point now? So the turning point, TP, the turning point, we know that the formula for x is gonna be, let me just erase this very quickly. The formula for x here is gonna be negative b over 2a. So what is our b? When you look at this, b is gonna be 0. Remember, we don't have b here. We don't have the x. And b is a coefficient of x. We only have x squared and constant. So b is 0 over 2a, which is a is 1 here. So our x is gonna be 0. But what about the y-intercept? The y coordinate of of the turning point. So we take it from the original, we substitute with the y, the x coordinate. So we have done that before, guys. You can see this here where x is 0. So this point here, this point A, it's actually a turning point and also the y-intercept. So you can also write it as a TP, right? Because whenever x is 0, we substitute it here. As you can see, y is gonna be 3. So it's the same as the turning point. So let's draw our graph. Let me just open a space here for a bit. So your graph is supposed to look like this, guys. Okay. Let me just, this line doesn't want to be straight. Let's do it. Doesn't look so good. Doesn't look so good. Now let's do this. There we go. Much better. Much better. Alright, so look, our x-intercept, our y-intercept is gonna be here. Let's call this one 3, positive 3. Remember, x must be 0. Our turning point is also here. So since when we look at our graph, our equation here, if a is positive, meaning our graph is gonna be facing up. Remember, guys, when a is positive, the graph is facing up. If a is negative, the graph is facing down. So we don't have the x-intercept, so your graph is gonna look like this. Since we don't have the intercept, your graph is gonna turn here, going up like that, and it's gonna turn there, going up like that. And that is your graph, guys. So this is 2 marks, y and x. So they mark the intercept and also the shape of the graph. I hope you guys understood how we do this one. Alright, guys, so let's go to question 5 and let's solve the problems. So let me just scroll here. Now this is question 4. We have to jump and only show question 5, right? All right, let me adjust. So this is question 5. Now let's start with question 5.1. So question 5.1, as you can see here, they want you to solve for theta if you are given the following expression here. We have cosec open bracket 2 theta minus 70 close bracket is equal to sec theta over 2 plus 10 degrees close bracket. Now they even give you a domain here. They say the domain should be 0 to 90. So basically theta should be greater than 0 or equal to 0, or less than 90 or equal to 90. So that is the domain, meaning now that is actually 90, the first quadrant. If theta should be less than it should be greater than 0 or equal to 0, or less than 90 or equal to 90. So it's supposed to belong somewhere here. So whatever the answer that you're going to get should be within this quadrant, which is the first quadrant. All right, so let's continue. Now when you look at 5.1 there, let me rewrite it so that you can be able to solve it nicely. We have cosec, inside there we have 2 theta, we have 2 theta minus 70 degrees. Okay, so this is equal to sec, and then inside the bracket we have half theta, or theta divided by 2 plus 10 degrees. Right, so the domain here is here. I can't write it here. I hope you can be able to see. Let me just highlight it with a red color and underline it. Right, so that is your domain. Now guys, it's time for us to solve this. In order for you to solve this, guys, you need to know the co-ratio rule. Let's look on our left hand side and right hand side. Look, on our left hand side we have cosec, the trigonometric ratio, and on our right hand side we have sec. These are co-ratios, guys. These are co-ratios. So we must change one of them to be like the other. You can choose to change cosec, or you can choose to change sec. So the best way of doing this, remember this is an angle. All of this is an angle inside the bracket. These are just angles. So the best way of doing this, I prefer to change cosec, but you can also change sec. It's fine. So how do you do it? You use the co-ratio. Remember, the co-ratio of sec x is what? It's gonna be cosec cosec x 90 minus x. Basically, that's a co-ratio of sec x. So in order for us to change this cosec to sec, we must introduce 90 as an angle here. So we must introduce 90 as an angle. So if you change this one, this is what you're gonna do. If you decide to do the other way around, which is gonna be cosec x, the co-ratio is the same as sec 90 minus x. Guys, I made videos about co-ratios. Let me just show you where you should go and learn about co-ratios, guys. Just in case you don't understand the co-ratios, there's a video on top there. Go and watch it so that you can understand what I'm doing here. Alright, but anyway, let's just continue, guys. Let's just continue. I will have to erase this. So we're gonna use the one underneath here, the cosec of the co-ratio of cosec. Okay, let me just do it here. So if we change this to its co-ratio, it's gonna be sec, and then remember 90. Now we have 90 minus, now we put everything inside the bracket there, 2 theta minus 70 degrees. Remember, you only change one trigonometric ratio, guys, and then the other one you leave it at that. So the other one is going to be cosec, and then you change nothing. Theta half plus 10 degrees. Then we close there. Hope you can able to understand that. Remember, if you don't understand, go watch the video there. Alright, so both sides we have sec and sec. Now we can drop this. Right? We can drop this. So let's drop this. So this is gonna be 90. Then we have to multiply by negative. So we're gonna have 2 theta plus 70 degrees. So here when we drop the trigonometric ratio, we're gonna be left with half theta plus 10. Okay, now it's time for us to group all the angles together and the what is this, the theta together and the angle together, guys. So if we take this half theta, first of all, let's take this 2 theta this side, let's leave it here, and take this half theta this side. So we're gonna have negative half theta, and then we continue there. And when we continue, let's say we take our 90 this side, transpose it, it's gonna be negative 90, 70 also, it's gonna be negative 70, okay, plus 10, okay, degrees. So these are just angles, guys. 90 and 70 will go that side. So if you add half 2 negative 2 theta minus half theta, you're gonna be having negative 5 theta divided by 2. in this side here, if you say negative 90 minus 70 plus 10, you're gonna be having negative 150 degrees. Remember, these are just angles. Now you cross multiply. Let's cross multiply with negative 2. If you cross multiply, you multiply by here negative 2 and you multiply by 1 there. Okay, that's what cross multiply is. Okay, that is we're gonna be left with 5 theta, and this is gonna be 300 degrees. So we divided by 5 here, divide by 5 there, and then theta is gonna give us 60 degrees. So this is your answer. Okay, this is your answer. Let me just go back here. Remember, the angle is supposed to be must be greater than 0 or equal to 0 or equal to 90 or less than 90 So 60, it does reach the requirement. It does fit in here. It's greater than 0 and it's less than 90. So this is our final answer, guys. 60 degrees. So it makes sense because this is only 3 marks. So this is not much of a problem. So guys, I hope you understood. If it so happened that you didn't understand, you can rewatch the video and see where you didn't understand this question. But let me explain here. Remember, we added by, someone can ask, why did we minus by 90? Why didn't we just use 180 or 360 or any other number? Now, first of all, you need to understand, you need to use the correlation rule. So the correlation rule is 270 and 90. And the reason why I use 90 instead of, the reason why I use 90 minus instead of 90 plus, you need to understand that, look at our cosec. Our cosec here is positive. So if you want to just change where cosec is positive, it's positive on the first quarter. So this represents first quarter. 90 minus is actually first quarter. So that's why we use 90 minus. Guys, but like I said, if you want to understand way much better, go to the video that I posted there and watch the correlation rule. Alright guys, so let's go and do the next question. Alright guys, let's continue. Now we have done 5.1. It's time for us to do 5.2. Okay, so this 5.2, they want you to prove that the left hand side is the same as the right hand side. Guys, as you can see, this question 5 is actually trigonometry. So you must know your trigonometry in order for you to solve this question 5. But don't worry, I made a lot of videos on trigonometry. I would recommend you to watch those videos just in case you forgot about some of the things. Alright, let's look at this, guys. So what we have here is this one here. Let me just highlight 5.2. So they want you to prove this side is the same as that side. Remember, whenever you prove, guys, you need to choose the side which is more complicated. In this case, the side that is more complicated is our right hand side. Right hand side is the one that is more complicated as compared to this. So I'm just gonna write the right hand side here. Remember, the left hand side is cos 2 theta. So let's do the right hand side here. Okay, let's take the right hand side. Okay, let me just rewrite it so that we can able to solve it nicely. So we have 1 minus tan squared theta. Okay, divide by, now this is gonna be something that is a bit long, divided by root, divided by 1 plus 2 tan squared theta plus tan to the power of 4 theta just write this 4, it's going to be positive. Okay, to the power of 4 theta. So this is what we have, guys, right? Now look, the numerator there, we can just leave it like that. Let's try to simplify this one here. All right, so let's continue here. So the numerator, we have 1 minus tan squared theta. We are fine here. But the denominator, let's put it under the root. When you look at the denominator, guys, this is a more like a trinomial. We have less, but it's coming, we're starting from the right going to the left. We have tan to the power of 4, which is the highest power. And then we have the second term, which is tan to the power of 2, and we have a constant. So that is a trinomial. We can factorize this. So let's start with the 1. The factors of 1, when you multiply, they give you 1 into 1 and 1. Okay. Now the factors of tan to the power of 4 theta, when you multiply them, when you add them, remember this is addition, so we have addition inside the bracket there. When you add them, they give you 2. It's gonna be tan. Okay, let me just do this. We need space, guys. Okay, we need space to do this one, so I didn't anticipate that. Okay, all right, let's do it. So we say plus here, 1 plus, these are the factors of 1, so it's gonna be tan theta squared, and another tan theta squared. Okay, I hope you can see tan theta squared, when you multiply them, they're gonna give you tan to the power of 4 theta, but when you add them, they're gonna give you 2 theta. So when you continue here, our numerator, it doesn't change, guys, to remain the same. You're gonna have tan squared theta. We're gonna have 1 minus tan squared theta divided by, now if you can see, this is repetition, so it's the same as 1 plus tan squared theta, and then everything squared. Remember, it's the same thing. This means the brackets are the same. Now with squared and square root there, we can able to have just create more space here, guys. I hope I'm audible, because I feel like I am not that audible. All right, let's continue. So yes, this is gonna be our, if we continue here, this is gonna be our, the root and the square, they're gonna divide each other, and then with the power of 1. So we're gonna be left with 1 on the numerator minus tan squared theta. Now divide by 1 plus tan squared theta. Right, so this is what you're left with, guys. So with this one, now it's time for us to solve. Remember, this question here, it's about 6 marks. Okay, it's about 6 marks, so it's gonna take a little bit of time for us to solve it. Okay, but as long as we are paying attention to what we're doing here, if you come across this, you can do it within few minutes of time. All right, so we have the numerator 1 minus tan squared, the denominator 1 plus tan squared. So what we do here, I always try to rewrite this so that we can able to solve this. So the numerator is 1 minus tan squared, and then instead of writing this line here, rather write division here, which is 1 plus tan squared theta. So this is our denominator. Okay, now it's time for us to change our tan. Remember, tan, it's tan theta, we can use the quotient identity, the same as sine over cos theta. So we can use this quotient identity to solve, to change this one. So we can say sine squared theta divided by cos squared theta. And then we can say the following here. We do the same thing this side as well. Plus, and then we can say sine squared theta divided by cos squared theta. Right. All right. So let's continue, guys. I need more space. I'm gonna create more space. I hope you can follow through, guys. Hope you can follow through, because with this we must able to find more space. Okay, so we need, on this one here, we need to find the denominator, the common denominator here. So it's gonna be cos squared theta. Okay, this is 1 into, remember, divided by 1 into cos squared theta is going to be cos squared theta multiplied by 1. So we're going to have cos squared theta minus, and then cos squared theta into cos squared theta is 1 multiplied by sine. So this is going to be sine squared theta multiplied by sine squared theta. That is what we do. And then we divide this here. We do the same thing here as well on this side. So we're gonna, common denominator is still cos squared theta also on this side. So we say 1 into cos squared theta, and it's going to give us cos squared theta multiplied by 1. So it's going to be cos squared theta. But here we have plus, so we can say plus. So we say cos squared theta into cos squared theta is 1 multiplied by sine squared theta. So it's going to give us sine squared theta. Alright, so now it's time for us to use the identities. This one here, if you continue, let's look at this. Cos squared theta minus sine squared theta. This is actually the double angle identity. So you can write it as cos 2 theta. This is a double angle identity, guys. I hope you know. Just in case you don't know, there is a video here on top here. It's gonna pop up here on top. Go and watch that video about double angle identity. Okay, so we divide this by what? Cos squared theta. Alright, so here we're also gonna do the same thing here. Now this one, these are square identity. Cos squared theta plus sine squared theta. This is a square identity. If you remember, cos squared theta plus sine squared theta, this is equal to 1. So we can say 1 here. We say 1 then divided by cos squared theta. Alright, now from here we can rewrite this as it is, cos 2 theta divided by cos squared theta. Now remember, we can multiply here, change this sign and make it multiplication. But when we change this sign to multiplication, don't forget that this here changes. The denominator becomes the numerator and the numerator becomes the denominator. So we're gonna have the numerator here, cos squared theta divided by 1. So since we have multiplication, cos squared theta and cos squared theta, they're gonna divide and they're gonna give you 1, and then we're gonna be multiplying that 1. We're gonna multiply that one with cos 2 theta. Now let's see if this is the same as the answer there. If you look at your, let me highlight here. If you look at your left hand side, so it's gonna be cos 2 theta, which is what we got here. Guys, this is how you basically do this one. At some point you needed to know your identities in order for you to solve this one. So you need to practice your identities, guys, in order for you to solve this one. Otherwise it will give you a serious challenge. Now let's move to the next question. Now guys, let's do the last question here, which is 5.3. So here they just want us to simplify the expression that you see there, so to be as simple as possible. So this is the last question on this paper, but I don't think it's the last question for question 5. So let's do it. 5.3. 5.3. So they want us to simplify the following. Let me just write it here. We have 1 minus cos 2x divided by tan x. Alright, so what you should do here, like I always do it, guys, it's better when you rewrite this and you have your numerator like this, and then instead you divide by division sign instead of this line. You have tan, because you need to change this tan. Alright, now when it's like this is the same as that one. Okay, it's easier this way. Now let's start. So here we do have double angle identity. Again, you need to know your double angle identities, guys. Okay, so we're gonna have 1 minus, so we need to change this into one of the double angle identities. You can change it to any of the two, in fact, because cos is about 3, but rather go with the other 2. So I'm gonna change this into 2 cos x squared minus 1. Just actually let's put the bracket there, guys. Okay, bracket is important. Just put the bracket there. I'm gonna change this into 2 cos squared x minus 1. Guys, this is one of the identities. So again, go here if it's so happen that you don't understand where this is coming from, but this is one of the double angle identities. Go and watch that video here, and then we can change this tan to quotient identity. So remember, tan is the same as sine over, wait, what's happening here, over cos x, right? All right, so when it's like this, we just multiply by negative to remove this bracket. If we multiply by negative, remember we have 1 here, multiply by negative, we're going to have negative 2 cos squared x minus 1, or plus 1. Remember, we are multiplying by negative. It's going to be positive. That's going to be negative 2 cos squared x, and then negative multiplied by negative plus 1. So it's going to be like that. And then here we have the quotient ratio, the quotient identity, guys. Doesn't change. It's going to remain the same. Okay, cos x. All right, so let's continue. Now let's look at this. We have 1 and 1. This is going to give us 2. So let's put it inside the bracket. It's going to give us 2. And then what we have here, we have 2 cos squared x. All right, and then we still divide, guys. Okay, I know this can be exhausting, can be time consuming, but I'm telling you guys, it's for your own understanding. Now here we take out the common factor. Let's take out the common factor. Our common factor here, as you can see, is 2. So we can say 2, and then we left with 1 minus cos squared x, right? And then divided by sine x over cos x. All right, now let's look at what is inside the bracket there. Let me just create more space while we're still looking. What is inside the bracket? Now let's look at let's look at what is inside the bracket. If you look at what is inside the bracket, guys, this is an identity, guys. Remember our square identities? We have sine squared x plus cos squared x is equal to 1. Now, if we take this cos to the other side, it's gonna be, when I left with sine squared x, and then we have 1 minus cos squared x. Do you guys see? Now this looks like that inside the bracket. Do you guys see? So meaning we can substitute inside what is inside the bracket with 2 sine squared x. So we have 2 sine squared x. And then from here we change the division here and make it multiplication. So we have what's going to happen when you change this division to multiplication? The cos become a numerator, and then the sine becomes a denominator. Sine x becomes a denominator. Now look, if we continue like this, let's keep on doing it. This sine x and that square, they're going to divide each other. Now we're only left with 2 sine x multiplied by cos x. Now this again is a double angle identity. Remember, go to this video, guys, on double angle identities, and you will see this. So this one is gonna be what? It's gonna be double angle identity for sine. So this is gonna be sine 2x. So that is your final answer. I hope you guys understand here this how we solve this one. It was not really that difficult. It's a matter of changing the identities, applying and using all the identities to simplify. Alright guys, I hope you understood. But if it so happened that you didn't understand, you can rewatch this and pay attention to identities as well. Now from here, it's time for us to move to the next question. Alright guys, now it's time for us to do 5.4. So 5.4, here we have 5.4 here. So you are given the following expression. You are given tan A is equal to 15 over 20, and A is an acute angle. It's an acute angle. Now they want you to, without using a calculator, determine without using the use of the calculator the value of cos 1 over A over 2. So I hope you can be able to see this. So here guys, we are not allowed to use a calculator. So without the use of a calculator, I want you to give us the value of this. Now they will see if you use a calculator, because there are steps that you're supposed to do to show that you didn't use a calculator. So we have to be very, very smart. Now let's see. Now we need to find, let's rewrite our time. We need to find our side. So we have tan is equal to 15 over 20. Now if we divide by what is this, by 5, if we divide the numerator by 5, we're gonna have 3, and then we divide the denominator by 5, it's gonna be 4. So we know that tan is opposite, which is y, over adjacent, which is x. We know that, right? So what is missing here? We need to find our r. So you can draw a triangle here. We can draw the Cartesian, what is it? Not the Cartesian plane, the cast diagram here. Or let's just say the Cartesian plane. Yes, let's draw our Cartesian plane here. I need this space. Let me draw it somewhere here, guys. Okay, because there's nothing big, it's nothing major here. It's nothing major. Nothing is not stable. All right, so let's draw it here. So we have x this side and we have y this side. Look, your y is 3, so it's gonna be somewhere here at 3, positive 3. So this is gonna be 3, and then your x is 4, positive 4. So it's gonna be somewhere here. Let's just make it 4 here. So if you combine this, or where they intersect, they're gonna give you this one here. Okay, let me just try to draw a straight line, straight here. Okay, so they're gonna give you this. So meaning we're gonna have the following there. Okay, so we need to find our radius or our hypotenuse. So because this is gonna be a, by the way, this is a. I hope you can see. So our hypotenuse, we have to use the Pythagoras theorem. So we know that I squared is equal to x squared plus y squared. So r, we can say square root. What is our x squared? It's going to be 4 squared plus 3 squared. Okay, and then our final answer here is going to give us what? It's going to give us, this is going to be 16 plus 9 is going to give you 25. So square root of 25 is going to give you 5. So that is your r. So that's your r. So this is going to be 5. I hope you guys can see this. Okay, now it's time for us to find this this one here. So this is a half angle, guys. This is a half angle. Cos, let me just put here, half a. This is what we call half angle. Again, guys, half angles. Oh, but before I show you, I've made videos about half angles. I'm going to show you where to watch those videos. So the formula for cos half angle is as follows. It's root or square root, then half, and then we have 1 plus cos a. There we go. Right? So we have to substitute them. Just in case you don't know where this is coming from, there is a video here explaining half angles, guys. Go and watch that video. We're explaining the half angle and deriving them. Okay, I hope you guys can able to watch and understand them. Now basically this is a half angle for cos. So what you need to do here is just substitute here. So let's do it. Now inside the bracket here we have 1 over half minus, or close bracket, open bracket, plus, open bracket, then 1 plus. Now what is cos a? Cos a, remember, it's gonna be, let me just write it here. Cos a, remember, it's gonna be x over r. So what is our x in this case? Our x is 4. It's gonna be 4. It's gonna be 4 over, what is our r? 5. Remember that. So cos, it's adjacent, which is this side, over hypotenuse, which is this side of A. Okay, I hope you understand. So instead of writing cos A, you're gonna write 4 over 5. So it's gonna be 4 over 5. There we go. Then from here, it's time for us to solve this. Remember, they want us to solve without using a calculator. So guys, they can tell if you use the calculator. They will tell if you use the calculator. Okay, I know this is long for 3 marks, but I'm telling you, once you understand, it won't take that long. So what do we have inside here? We can even do it this way. Okay, what do we have inside the bracket there? We have half, and then we need to find the common denominator. So our common denominator here is 5. So 1 into 5 is 5 multiplied by 1, so it's going to give us 5 or plus. And then 5 into 5 is 1 multiplied by 4, it's going to give us 4. Okay, let's just create another space, but we are done, guys. We are done. Okay, so we're going to have the following. Let me just drag the question down here. Okay, all right, so we will be having half here, right? And then let's see what do we have here. This is going to be 9. 5 plus 4, that is 9, divided by 5. So yeah, this space now is not enough. Okay, let's create more space. Okay, we have enough space here on this app, so we cannot be stingy with space. We cannot be stingy with space, guys. Okay, all right, let's create space. There we go. We have half, and then here it's 5 plus 4 is going to be 9 divided by 5. There we go. So if you continue here, if you continue the root, if you say 1 multiplied by 9, we have 9, and then 2 multiplied by 5, we have 10. So your final answer here is going to be 3, because the square root of 9 is 3 divided by root 10. Guys, this is your final answer for this question. So this is your final answer for this question. Remember, they say do it without using a calculator. I hope you managed to get this one, guys. If there is a shorter way of doing it, I would like to know about it, guys. Okay, but I think this is a way of doing it for me. Anyway, we are done with this question. If it so happen that it's something that you missed, you can always go back to that section of the question and do it. Remember, we have timestamps here, guys. Okay, we have timestamps. You can click on the timestamp on the question that you want to do underneath there. All right, it's time for us to do the next question. Now, this is last question of this question paper, which is 5.5. I hope you guys are ready for this one. So in this one here, they just want us to simplify, right? It's about 4 marks, nothing more. So this one here, it will require you to understand the use of 180 rule and the correlation rule. So let's see if we can able to solve this one here. Okay, now guys, let's do it. So let me just write here 5.5. Let's rewrite it here on our screen here. Okay, let's rewrite it. Let's do this. So we have tan. Let's hope you're gonna have enough space, minus theta. Okay, multiplied by sine, and then 270 minus theta, right? and then we have cosec. Oh, I don't know if this is gonna fit, guys. Let me just, but it still appears there. Multiply by cosec theta. This is theta, and then we divide by divide by sine minus theta. Okay, multiply by cot. 90 minus theta. Okay, and then multiply by cos 180 minus theta. There we go. I hope you can able to see this, guys. Okay, so this is our question. Now we need to simplify this, guys, so we need to use the reduction. Guys, in order for you to do this one, you need to know your 180 rule and your correlation rule. Already the correlation rule I uploaded here. Let me just do this. Already the correlation rule, it is uploaded here. So I'm gonna also upload the 180 rule. That video that pops up there is the 180 rule. So whatever I will be doing here, it's from that video, the basics. All right, so let's continue. What's happening here? All right, let's continue. What's happening? Yeah, right, let's create more spacing. Okay, so let's do it. Now let's start with tan negative theta. So negative theta, guys, where is negative theta on our class diagram? If this is theta, if this is 0, I mean, and that is 360, negative theta, and that is 90, and that is 270. Negative theta is when you are going this direction. Okay, when you're going to this direction, which is the fourth quadrant. So tan on the fourth quadrant is going to be negative. So hence you're going to write it like this: negative theta. Okay, let's go to this one here. Now sine 270 minus theta. This is the co-ratio rule. Remember, you must go and watch that video. Now, what's the co-ratio of sine? So the co-ratio of sine is cos. But then, where is this happening? What quadrant is this? 270 minus. So if we have 270 minus, so it's going to be the third. So this is 270 minus theta. So this is the third quadrant. So sine is not positive, so it's going to be negative. And then what is the co-ratio? The co-ratio of sine is cos. Do not forget, guys, it's easy to make mistakes here. And then the cosec, it's cosec. But what you can do here, you can say 1 over. What is the reciprocal or the inverse of cosec? It's 1 over sine theta. There we go. We are fine. All right, let me just do this. I don't like doing this, but I think this is gonna be fine. And then let's look at our numerator there, our denominator. Again, we have negative theta. So where is negative theta? It's where we go this side. So this is gonna be negative theta here. So the negative theta on our class diagram is at the fourth quadrant, and sine is negative, so this is gonna be sine theta. Okay. And then now multiply by our cot 90 minus. So guys, cot 90 minus, for the fact that we see 90 here, this is gonna be the co-ratio. So what is the co-ratio of cot? It's tan. So we are fine with tan. So where is this happening? This is 90 minus. So 90 minus is the first quadrant. Remember, first quadrant, all the trigonometric ratios, they are positive here. So it's going to be tan theta. There we go for this one. And then for that one here, the last one, we have cos 180 minus theta. So this is a 180 rule. Whenever you see 180, remember guys, it's a 180 rule. If you so happen to remember this, guys, go to those videos that I post there, guys. Go and watch those videos. Very, very important for you to solve this. All right, so multiply. So 180 minus, so with 180 minus, where is that quadrant? 180 minus is the second quadrant, with this quadrant here. 180 minus theta. So the second quadrant here, we know that cos, it is not positive, so it's going to be negative cos. There we go. So we continue. We are done now. We are done. So here, if we continue here, look at this. We have to change this. We can say this one. We can say the quotient. Remember the quotient identity. We can say negative sine, right? Negative sine theta. Remember for this time over cos theta. Okay, it's for this term. Multiply by another negative, multiply by negative. If we multiply this, this is gonna give you negative cos theta over sine theta. Okay. All right, divide. Like I said, I don't like this too much confusion, but it's fine since we don't have enough space. So we're gonna have this side, we're gonna have negative sine theta. We change this as well, the quotient identity. So we're gonna have sine theta over cos theta. Multiply by cos theta. Okay. So these ones are divided by 1, by the way. These ones are divided by 1. Alright, let's continue, guys. Let's continue. Let's create more space and let's drag our question paper down here. Alright, so let's do our question here. On the numerator, look, we have cos and cos. We're going to give you 1. And we have sine and sine will be divided, give you 1. Negative and negative, that is going to be positive, so it's going to be 1. Remember this negative, that negative. So the answer here on the numerator is 1. Divide by. Now let's look at the denominator. We have cos, divide by cos. Right? Hey, let's not forget this is negative. Okay? Right? And then we have negative 1 multiplied by sine, which is going to give us negative sine, multiplied by negative sine, it's going to give us positive sine squared theta. So our final answer here, what is the reciprocal of, or the inverse of sine x? It's going to be cosec x. Remember the inverses? Go and watch those videos about inverses here, guys, if you don't understand. So there will be a lot of videos, guys. Go and watch them there. So our final answer is gonna be cosec squared theta. Guys, I hope you managed to understand this one as well. This one, in order for you to understand this question, the last question, it requires you to know your 180 rule and your co-ratio rule. Finally, we are done with this question paper. So this was a very, very long question paper, guys. That's why I sectioned it into each question. But then if you don't mind watching the whole question, then no problem. Guys, again, if you want to watch the video in a way, if you want to watch a certain question, I mean to say, you can just go to the timestamp and click on that timestamp, and then you watch that specific question, because I made timestamp again. And again, guys, if you haven't subscribed and you're new to this channel, subscribe to this channel, because I'll make more question papers, we'll solve more question papers, and also we want to do lots and lots of videos. Guys, there are lots of videos on the playlist. Go on the playlist there and watch the topic or the chapter that you want to learn about more. Thank you very much, guys, for watching. Do not forget to share these videos to your friend, and also like and comment if there's anything that you like to comment about. Until next time, guys, cheers.